The number one question I get asked, especially at this time of year, is what exactly do I need to do to achieve my target grade in GCSE maths? And that's the right question to be asking, because if you're studying 10 subjects and revising for around 3 hours a day, that gives you just 18 minutes per subject, if you split your time evenly. So you can't afford to revise everything. You need to focus on the topics that will move your grade the most. That's exactly why I built TGMT Live, a structured library of resources designed to help you maximise your grade in minimum time. Everything is organised by exam paper, so you know exactly what to revise and when to revise it, instead of guessing and hoping for the best. Live, interactive revision lessons focused on the key topics you need to prioritise this year. Paper-specific revision quizzes that generate 2 reports, giving you a clear, personalised revision plan. A fully organised lesson library, broken down into units, so you can go straight to the exact topics you need and track your progress. Priority access to revision booklets with work-along videos for deeper topic understanding. Priority access to practice papers with work-along videos focused on high-impact exam questions. Paper-specific checklists, plus an 84-page ultimate revision guide. So if you're feeling overwhelmed by how much there is to revise, TGMT Live gives you a clear system to follow. A one-stop hub for paper-specific GCSE maths revision, built around efficiency, and getting the maximum result from the time you actually have. Okay, so looking at our first question, we're going to look at using a calculator. And whenever you are doing a using a calculator question, you need to replicate what's on the page on your calculator screen. So for this question here, we would start by using the fraction button and then typing it in exactly as we see it using our power button. You can use the squared button or you can use the empty power button, which I'll use in just a second. We've got our square root button we need to know how to find. And then again, just typing it all in, just being careful if you need to come out of the square root. But once you've done that, we can write our answer out. This one wants it to 4 significant figures. So we'll chop that after our 4th number and round it as we need to. Okay, so this question says Owen uses a code to open a lock. The code is a letter followed by a 2-digit number. The letter is L or U, and the number is a prime number between 20 and 30. Write down all the possibilities. So the prime numbers between 20 and 30, we just need to think about the odd numbers between 20 and 30 that don't divide by anything. So 21 divides by 7 and 3. 23 doesn't divide by anything, that's prime. 25 divides by 5. 27 divides by 9, and then we have 29. So we only have a few numbers that are prime between 20 and 30. So in terms of listing the sort of possibilities that we can have here, we could start with the L or the U and then put our prime number with it. So we could have 23 alongside the L, and we can also have 29. So 2 of the codes could be L23 or L29. We can have exactly the same numbers, but with the other letter. So we can have the letter U, which could go with 23, and we can have the U, which goes with 29, and there's our possibilities for Owen's code. When we have indices and we are dealing with numbers, we could be asked to write the value of this. However, if we were asked to write the value here, we could just type this into a calculator. But this one says write it as a power of 3. So if we're going to write it as a power of 3, it's easier for us to apply our index laws. So when multiplying, we can add the powers. So on the numerator there, we can simplify that 3 to the power of 7 times 3 to the power of negative 2 by adding the powers. And not forgetting, you can use your calculator for those negative number calculations. So we need to do 7 add negative 2. You can do that on the calculator, but it comes to 3 to the power of 5. We then have 3 to the power of negative 3 on the bottom. Now, when we are dividing, we can subtract the powers. So the next calculation that we need to do is 5 take away negative 3. And again, you can type that into the calculator, but two negatives next to each other like this turn into a plus. So 5 add 3 would give us the power of 8. So we have 3 to the power of 8. Now the question here does say to leave it as a power of 3, so our final answer would be 3 to the power of 8. That's all that leaving it as a power of 3 means. Now for this next question, we have some lowest common multiple and some highest common factor. And we have some of these numbers written in prime factor form. So if we have a look at first the lowest common multiple, the way that I do the lowest common multiple, particularly when I have a calculator, is just to write a list of their times tables. Now I like to draw a table for that, and it might be that we need to do quite a few numbers, but do pick the number carefully. I know how to spot numbers that will divide by something like 40 because it has to end in a 0. So it makes sense here for me to start on the 56. Now all I would do on a calculator is just keep adding 56 until we get to a number that might divide by 40. So if we keep on going and we keep adding 56, eventually we're going to get to a number that ends in a 0. And as it happens, our next number here is 280. Now I don't need to write down all of the multiples of 40. All I need to do is see if 280 divides by 40. Well, 280 divided by 40, which we can type on the calculator, comes out as 7, which means the 7th number along my list is going to be 280. So therefore my lowest common multiple will be the 280 that we've just found. Now of course, if at this point 280 did not divide by 40, I could have doubled the 280, which would be the next time in my list that I would see a number that ends in a 0 and try dividing that by 40. But there we go, as it happens, it did divide, so 280 is our answer. Now for part B, we are given two numbers as a product of prime factors, and it says to write down the highest common factor. Now this is typically a 1-mark question, and what we could do is we could type these numbers into the calculator and apply a highest common factor method. However, these are quite large numbers. 2 to the power of 3 times 5 is 120, and 2 squared times 3 times 5 squared is 300. Now it might be that that's okay for you to find the highest common factor of, but there is an easier method. If you write these numbers out in the sort of long form, so 2 times 2 times 2 times 3 times 5, and our other number, 2 times 2 as it's 2 squared, times 3 times 5 times 5, all we actually have to do is identify the numbers that are in both. They both have a 2, they both have another 2, they both have a 3, and they both have a 5. Now whatever's in both, we're just going to multiply all these four numbers together. So 2 times 2 times 3 times 5. And again, I'm just going to type that in on the calculator, and it gives me an answer of 60. So when finding the highest common factor, you just need to find which of the prime factors are in both, and including any duplicates that are in both. So in this one, there was two 2's in both numbers, so we did use both the 2's, and just multiply them all together. That is a method that you can use if the whole numbers are given to you rather than the product of prime factor versions. You can find the product of prime factors and multiply the numbers that are shared in both. But there we go, there is some lowest common multiple and highest common factor. Now our next question is looking at standard form. If we're asked to write a number in standard form, you can just type it in on your calculator. Now it might not always give you the standard form version, but you can convert it and have a look, and if it doesn't, don't forget you can always hop the decimal in and just remember it's a positive power for a large number or a negative power for one of these 0-point numbers. For a larger question, when we have to type quite a lot in, you may have to use your fraction button, but we just want to replicate exactly how it looks on the screen, and not forgetting this button here where you can put any power in. Remember to come out of the power by pressing that right key, and then you can type in the rest of everything there. Remembering that if you have a negative power, like we have on the bottom here, you can use either the negative button or that subtraction button to put that negative in, but I do tend to always stick to using that negative button here, so I just don't make any mistakes as I'm going along. But here we go, clicking equals, we've got our final answer, and we can write that down in standard form, and there is some standard form. And looking at some percentage change. Now this question says Liam paid £245 for his insurance and the next year it went up to £883, and it wants us to work out the percentage increase. Now whenever we're looking at a percentage change, whether that's an increase, decrease, a profit or a loss, we'll always tend to follow the same approach. We'll first follow the actual, or work out the actual monetary increase, which has gone from 883 from 245. So if we subtract 245, we have £638 increase. Now whenever we're working out a percentage change, we just do the change divided by the original and multiply that by 100. Now you can see in this question that the actual amount that it's increased by has gone up by more than 100%. It's over doubled. So we are going to get a large percentage here, but let's put the numbers in and see what we get. So we have 638 as the change. The original was 245, and we're going to multiply that by 100. Now you can type this in 2 steps, or you can type it in as a fraction and just put it all in one go. That's how I'm going to do it. And I get quite a strange decimal here. It comes out as 260.408163 and a few more decimals. Now this question doesn't say to give your answer to a certain amount of decimal places. Now, that doesn't mean that you've gone wrong, so you shouldn't be put off by numbers like this. Typically, in a question like this, I would just write down every number on my calculator screen. I would stop after 7 decimal places because some calculators only go up to 7 decimal places. So if we were going to write this, and you can use your S to D or decimal conversion button on your calculator, but for me, to 7 decimal places, it comes out as 260.4081633, and I just leave it like that. If it asks me to round the answer, then I would, and it does feel a little strange in a question where it doesn't say something like round or give your answer to 1 decimal place. But there we go, as long as you are confident that you have done your method correctly, you've gone back, you've double checked it, sometimes numbers like this can appear in a question. Now this question, we are looking at an error interval. It says the length of a pencil is 126 millimetres, correct to the nearest millimetre. So the first millimetre is this units here, the 6, so it's correct to that 6. So it's 126, but it could be point something, it could be just below. Now this asks us to write down the error interval. Now it can help to draw a little number line here, but to get the upper bound, the number on the right, we actually have a nice or relatively easy process to get that. Now the next millimetre above 126 is 127, and below 126 is 125. With an error interval, we're looking at those cut-off points or those midway points between those numbers. Now in between 125 and 126 is 125.5. And in between 126 and 127 is 126.5. So they are the bounds that we're going to put on the left and right within our error interval. So we're just going to put the 125.5 on the left and 126.5 on the right, and there's our error interval. When looking at collecting like terms and simplifying general expressions like this, we just need to be careful, particularly on this part B question where we have some powers involved. Now on the first one, we have simplifying 5p, take away 3p, and then plus, and we just have this letter p. Don't forget, although it's not written, there is a secret 1 in front of that p, so just remembering to count those up as we go. Now we want to simplify this so it's just one number in front of p, as we only have that one letter there. So first start by doing 5p take away 3p, which leaves us with 2p, and then we are going to add 1p. So 2p add 1p leaves us with 3p in total, and there we go, we've simplified that. For the next one, we have m cubed plus m cubed, and again, the fact that these don't have the secret ones written in front of them might accidentally throw us into thinking that this is an index law rule where we have powers. Now this is not all we are doing, we're collecting these, we're saying how many m cubes there are. Well, you can see there's 1m cubed plus another 1m cubed, and in total that is 2 lots of m cubed. Not to be confused with a question where we are doing m cubed multiplied by m cubed. And in that circumstance there, we have the index law of adding powers. So this is a very different question, so be very careful. This is the scenario where it would turn into m to the power of 6. For our final question, we have simplifying with different letters and we have a number in there. So if we have a look, we want to look for the like terms. It doesn't matter which one we start with, but one thing that stands out is there is only one number in this. So we'll stick with the number, which is going to be 10. We then need to have a look at either the C's or the D's. I'm going to start with the C's as it's written next and not forget to include that symbol that's written in front of it. So here I have 3C and I have a minus 7C. Now I have a positive and a negative there, so I'm just going to type it in on my calculator. 3 take away 7 is negative 4. So that leaves me with negative 4C. If you're not 100% confident with negatives, just use your calculator. We are practicing for using a calculator with this video, so we're going to use this at every opportunity. For the D there, we have 5D and we have 1D. Again, writing that 1 in. Both a positive, so that's a nice one. We have 5 plus 1, which is plus 6D. And there we go, there's our final answer. 10 take away 4C and plus 6D. For this next question, we have some substitution and changing the subject, and we have quite a difficult formula up here, in the sense that we have 4m squared. Now, before we look at what we need to substitute into this formula, we just need to think about what 4m squared means. It means 4 times m squared. And when you think about your order of operations, you always do your powers first. So the first thing that we need to do is do this m squared, and then we'll worry about the 4 multiplied by that and then taking away 11. So here it's asking us to substitute negative 3 into m. Now when you are substituting a negative number, you need to make sure that that number goes in brackets. So when we are doing m squared, if I do this, I write this out in one go, we have 4 times, in brackets, negative 3 squared, and then minus 11. As we're using a calculator, we can actually now just type that all in one go. You do need to write the negative 3 in brackets though. And if you have a calculator in front of you, you can test this out. We get 25. But if you test out writing in negative 3 squared, and just negative 3 with no brackets squared, you'll see that you get very different answers. When you do a negative multiplied by another negative, the answer is positive, so we get positive 9. However, if you type in negative 3 squared in the calculator, you will get negative 9, which is incorrect. And that's purely because your calculator will do the powers first, and then it'll do the negative version of that, as your calculator follows the order of operations, so do make sure you put a bracket around any negative numbers when you are putting them in the calculator. For part B, it asks us to make p the subject of the formula, and it's a relatively nice formula. We just need to first do the inverse by getting rid of this 4, and to get rid of the 4, we would subtract 4 from both sides. That means we get the expression on the left, d minus 4, and that's now just equal to 3p. To get rid of that 3, we have to divide by 3, and when we divide by 3, it creates a fraction on the left, it gets rid of the 3 on the right, and we just end up with d minus 4 divided by 3, and that is now equal to p. P is now on its own. It doesn't matter whether P is or the subject that you're looking for is on the left or the right of the equal sign. It's now on its own. Typically on a dotted line, it might say P equals and then give you the dotted line. And then in that situation, we would just write d minus 4 over 3 and just swap those pieces over. Now for this question, we are looking at some laws of indices. So we mentioned a question earlier where this might have tricked you when it was a plus in the middle, but here we are multiplying and we have the same base letter. So when we have this situation, we can just add the powers. So we would just add the 3 and the 5, and that would give us n to the power of 8. For the next question, we are dividing, but we have 2 different letters involved, and one of those doesn't have any power written with it. So that D on the bottom doesn't have a power, so we'll just put in the little secret power of 1 that's written in there, and then we can actually go about subtracting the powers here. So looking at the C's to start with, and do look at them separately, I'm looking at the C to the power of 3 divided by the C to the power of 2. Now when we subtract the powers, that leaves us with C to the power of 1. You can write the power of 1 in if you like. You're not going to gain marks or lose marks if you write it or don't, but typically you won't see that power of 1 written anywhere. For the d, we have d to the power of 4, and then we have d to the power of 1. If we subtract those powers, we end up with d to the power of 3. Typically, I wouldn't write it with that power of 1, so I would just write cd to the power of 3. And there we go, there are our laws of indices when multiplying and dividing. Now we have another law of indices here, but we're primarily focusing on expanding and factorising in this question. Now when you have powers in brackets, all you need to do is multiply the powers. That's a quick trick really, because x to the power of 3 to the power of 5 actually means x to the power of 3 times by itself 5 times. Now it would be a long process if every single one of these questions we wanted to rewrite it, but as a fail-safe method, you could write it out 5 times, and then we just add up all those 3's. If you add up 5 3's, that's just the same as doing 5 times 3. So our answer is x to the power of 15. For the expand question, we have 2 sets of brackets, and noticing in that second bracket we have 4 minus 2x, which is always something that might throw you. So just be really careful here. We are multiplying the first bracket by 4, and that would become 4x plus 12. And the second bracket we are multiplying by 7. So 7 times 4 is 28. That's going to be positive 28, so plus 28. And then 7 times minus 2x will be minus 14x. Now that's the expand part. We now just need to simplify and collect the like terms. Again, it doesn't really matter here which you collect first. However, having an awareness of the symbols here might just encourage you to add the numbers together first, because we have 12 add to 28, which is equal to 40. And then we have the 4x minus 14x, which will give us a negative. And it's just a little bit nicer looking if we put the negative in the second place here. But we can type this into a calculator. 4 take away 14 is minus 10 or negative 10. So minus 10x. You don't have to write it that way around. If you did the x's first, you could have written this as minus 10x. You'd have then just had plus 40 with it. We just have that one extra symbol. Either way is absolutely fine though. For part C, it asks us to factorise fully. Now when it says this word fully, it does mean there's more than one thing that can come out. Now if it just said to factorise it, we could actually just take a number out, or a letter. Which means if we look at these pieces, we could spot that they both divide by 3. And you could just put 3 on the outside of the bracket, and if we did that, we would have 5x cubed, which is what you have to multiply by to get to 15x cubed, and then you would have x squared y, which is what you need to multiply by to get 3x squared y. So worst case scenario, that would get you 1 mark on one of these more difficult factorising questions. However, when it says to factorise fully, we do need to try and see if we can spot a number and anything else that goes out the bracket. So we already know 3 goes outside the bracket, and this expression has an x in both, and actually there is a highest power of x squared in both. The one on the left is an x cubed, but we have an x squared on the right. So we can actually take out a power of x, which is to the power of 2. That does make this question quite tricky. But now if we think, what do we times 3x squared by to get to 15? Well, that's going to need a 5. Will that turn into an x cubed? No, we would need another x with the 5. We keep the symbol the same. What do we times 3 by to get to that 3 on that right piece? Well, that's just 1, so we don't need to write it. X squared is already in that as well, so we would just need to put a y in that second part of the bracket. Now there are probably 4 or 5 different ways that you could factorise that particular expression. It's quite a difficult one. But fail-safe method, just make sure you always factorise a number out at least, just to make sure you guarantee at least 1 mark on the question. But there we go, there is the factorised fully version to finish it off. And on to expanding and factorising quadratics. So here we're going to start with expanding and simplifying a double bracket. So we have 4 multiplications to do. We're going to first multiply the 5x by both pieces in that second bracket. 5x times 2x will give us 10 with x squared. And 5x times negative 3 is negative 15x. We can then move on to the 2, so 2 times 2x, and that's positive 2 times 2x, so positive 4x. And then positive 2 times negative 3 makes negative 6. We can then collect together these middle terms, and we have 10x squared at the start, negative 15 add 4, and in this circumstance here, remember to use your calculator, negative 15 add 4, which is just negative 11, so negative 11x, and then minus 6. And there we go, that's our final answer, and typically most double brackets will look like this when expanded. They will usually be in this format where we have an x squared piece, an x in the middle, and a number at the end. On to part B, where we are factorising. In this circumstance here, we want to find the numbers that go into our double bracket. They both will have an x at the start, as it's again just an x squared at the start of this quadratic. We want the numbers that multiply to make 12, so we could have 1 and 12, 2 and 6, or 3 and 4. We are looking for the pair of numbers that add together to make 7. That pair of numbers is 3 and 4. You can do a process of elimination going down your list, but that is plus 3 and plus 4, and they can be written in either order. Other than these two, there is another type of quadratic which is worth knowing about, where you have an x squared minus something like 16. Now in this circumstance there is no x piece in the middle, and that's because this is called a difference of two squares. And this is the one situation that's slightly different to both the ones on the screen. When factorising a difference of two squares, you are looking for the numbers that multiply to make 16 but will combine to make 0. And that is always going to be the pair of numbers that are identical. And in this case that's 4 and 4. The only difference being one is plus 4 and one is minus 4. So that's the one unique scenario outside of these where you have a difference of two squares. So looking at product of primes and highest common factor. Now part A here says to write 156 as a product of its prime factors. Now there is one button you can actually just click on your calculator and it will do the product of prime factors for you. I have got a video which I'll link in the description, which is like calculator hacks, where you can type this in. So I'll link that in the description. If you want to see how to do this in one button, then you can do that in that video. Now, if you don't have a calculator that does that, we still need to be able to answer this. So we need to find numbers, and typically, if it's a calculator question, we would expect the number to be a little bit more complicated. So what I can do is I can just do 156, and I can divide it by, and just pick a prime number. So I'll divide it by 2, as I can see it's even, and we get 2 and 78. So I'll circle the prime and I'll just keep going. Now that divides by 2 again, so we'll divide by 2 and it gives me 39. 39 doesn't divide by 2, so let's click divide by 3 and that works. We get 3 and 13, and I actually know 13 is a prime number. If you weren't sure though, because there was a question which came up where 31 was one of the numbers here, and I think a lot of people questioned that and thought, is 31 a prime number? So if you're not sure, just divide by 2, divide by 3, divide by 5, and typically I'd also try dividing by 7. That isn't necessarily going to cover all numbers in existence, but typically testing those 4 numbers is going to be enough that you'll be pretty confident whether it is a prime number or not. So 2 times 2 times 3 times 13, or 2 squared times 3 times 13. Now, when we are finding the highest common factor of numbers like this, you might want to use a prime factor method to find the highest common factor. You might prefer just to find the factors of 130, which won't take you too long to do, and just see if they fit into 156. So for example, 130, we know it's 1 and 130. I can, on my calculator, if I want, just do 130 divided by 2, and there we go, 65. So I can get these answers relatively easily. I can then do 130 divided by 3, that doesn't fit, so I can keep on going. 130 divided by 4 is not going to work there because we can see 65 doesn't halve, but it does divide by 5, so 5 and 26. We can keep going, we should know that it divides by 13, so we know we're going to get 10 and 13. It's just whether any of those numbers in the middle there are also going to divide. So on my calculator I'll just do 130 divide by 6, that doesn't work, divide by 7, that doesn't work, and then just testing the last few, and there we go, none of those numbers work. So I'd want to test 11 and 12 as well. I already know that they don't divide, but from here I would just look at these largest numbers, see if they fit. 130 doesn't, 65 doesn't, I'll have to test 26, that's not one that I would know off the top of my head. And actually, there we go, 26 is the one that fits. Now that's one method of approaching it. The other method that you could use, if you prefer, is to find the prime factors of 130. So 130, which if we were to do that relatively quickly as a product of prime factors, we could go 10 and 13, and then 2 and 5. So it's 2 times 5 times 13. Now once you've got them both written as a product of prime factors, any numbers that are in both, and again we'd want to write this in its long form ideally, above, any prime factors that are in both, so we have a 2 in both, and we have a 13 in both. To find the highest common factor, you just multiply those two numbers together. So we link those up, times them together, and we get 2 times 13, which is 26, which of course we already knew anyway, but there we go. There's two different methods that you could use for finding the highest common factor, because you never know if those numbers are going to be quite difficult, and if they are, writing out a list might not be the best method. Of course, the numbers might already be given to you in prime factor form, in which case knowing this method is going to save you a lot of time. A slightly harder, changing the subject of a formula here as we have this square root involved. Now if we have a square root involved in a formula and we need to get rid of that in order to unlock the subject, the way to get rid of a square root is to square both sides. Now if we square the left hand side, that becomes t squared, so that's quite nice. And when we square the right hand side, it's quite strange to write this. Really we should put the whole thing in brackets, but if I just put a little squared here, all it does is it just gets rid of that square root. So then when we rewrite it, we have t squared is equal to g plus 5 over 3. Now the next thing, locking that g in place, is this divide line. We have this 3 underneath, which means to divide by 3. So to remove this divide by 3 process, we would need to do the inverse, which is timesing by 3. So when we times both sides by 3, we end up with 3 lots of t squared on the left. We don't need to put the times sign, we can just write 3t squared. That's now going to equal g plus 5, as that whole multiplication by 3 just removed this divide by 3. There's now only one step left, and that is to get rid of that 5 so that g is the subject. To get rid of a plus 5, we will minus 5, and when we minus 5 from the left hand side, we have these 3t squareds, then take away 5, and that is equal to g. And again, if you have g equals on your dotted line, you would just write 3t squared minus 5, or you can write it either way round, 3t squared minus 5 equals g, or g equals 3t squared minus 5. When we have to draw inequalities on a number line, really nice to remember the circle, which we are going to draw above each number, just goes above the number or numbers in the inequality. Now in this first inequality, we have x is greater than negative 1. So we will put a circle above the negative 1, and we're going to point the arrow in the same direction that the inequality is pointing. Now, if you look at the way the inequality is pointing, it creates an arrow which points in the direction that we want to point our arrow. So we're going to point it to the right. It doesn't matter how far or how long along the number line you draw that, as long as it's pointing in the right direction. You just need to take into account that if the inequality has the extra line underneath it, you have to put some extra ink inside the circle and colour it in. Now this one doesn't, so we don't have to worry about that. And there we go, that's our number line that shows numbers greater than negative 1. For part B, we have a joint inequality where it is showing numbers between negative 2 and 3. So this time we have two numbers in our inequality, so we will have a circle above both, negative 2 and 3. We're going to join those together and we're pretty much finished. We just need to have a look and see if any of these inequality symbols have the additional line on. In this question, the one on the right has the extra line with our inequality, so meaning that it's also equal to. So all we do is we colour that circle in, and there we go, that is our inequality on a number line finished. Now with column vectors, usually the first part of these questions is really nice to get some marks on. You just need to know how to draw them if you're asked to label it on a grid. So here it says there's two column vectors, 5 over 2 for A and 3 over negative 1 for B. The top number indicates left and right, the bottom number indicates up and down. It says on the grid, draw and label the vector a minus 3b. Well, a is 5 and 2. We just have to take away 3 lots of b. So to work out 3b, all we have to do is multiply those numbers in the bracket by 3. So 3 on the top becomes 9, negative 1 on the bottom becomes negative 3. So I'll now put this down into my calculation. We have 9 and negative 3. Now with column vectors, this one is a takeaway. If it was a plus or a takeaway, all you do is you look at the top number, do whatever it says in the middle, and then look at this number. So we have 5 take away 9. Again, we're using a calculator, so we don't have to worry about negative numbers. 5 take away 9 is negative 4, which means left 4. On the bottom, we obviously have 2 different numbers, but I'm going to look at those together. So 2 take away negative 3. I can just type that into the calculator as well. I don't need to worry about that double negative. 2 take away negative 3 is positive 5. So 5. So this vector here actually means left by 4 and up by 5. Now if I am going left by 4 and up by 5, I need to start somewhere on the grid that gives me enough space to go left by 4 and up by 5. So if I'm going left and up, it might be a wise idea to start somewhere in the bottom right of the diagram, or of the grid. So if I go left by 4, and I'll draw some guidelines in here, 1, 2, 3, 4 left, up by 5, 1, 2, 3, 4, 5. There we go, it fits on the grid, it's going to take me to there. So to draw this, all I actually have to do is connect those together. Using a nice straight line, I'll draw an arrow in the direction that I was going in, so going left and up. And then I'm just going to label it, so a minus 3b. And there we go, drawn on the diagram, that is the vector a take away 3b.
So with identifying types of graphs, there isn't really an approach that you can use to work this out, so to say, but you need to just recognise what these types of graphs actually look like. So question or graph A here, that is an x squared graph. You have a positive and a negative variation of your x squared graph. This one, it makes this U shape. A negative x squared is upside down. It makes this almost N shape. So recognising those is your starting point. You then have to look at your cubic graphs. So cubic graphs are these ones here, where we have this almost wiggle in the graph, and there's another one just there. So both of these are cubic graphs. Now the x cubed graph on its own only has one root. It passes through 0. So this one down here is the x cubed graph. The one in graph B just has some additional things along with the x cubed. But it still starts with x cubed. However, this one that we're given here, y is equal to x cubed, is graph F. Moving on to some other graphs, graph E is a straight line graph. So this would be y equals, and then maybe something like x plus, and then let's just make up a number, something like x plus 3, if the y-intercept here was 3. Of course, you can have a graph that's sloping downwards as well, and that would have a negative x value in terms of its gradient. The only two that are left over are our reciprocal graphs. So we have graph C and graph D. Now the 1 over x is a reciprocal graph. Now when we have part of the curve in this positive quadrant of the graph, that's where it's a positive 1 over x. The other graph, which we have over here, which is also a reciprocal graph, it has it in the negative quadrants of the graph. So this is where we have a negative 1 over x, or something along those lines. So here, this graph here is graph D. Now, as well as those 6 graphs there, you also need to have a recognition for the trigonometric graphs too. But this one here is just looking at your standard quadratic, cubic, reciprocal, and of course, straight line graphs.
With simultaneous equations, we need to make sure the coefficients of either x or y are the same. Now, my personal preference is I always go for the coefficients of y, so that I'm going to stick with that for this question. If you do the x's, that's absolutely fine. You can always stick to your method, but I always go for the y's. Now, to do that, we need to multiply this top equation by 3. to make sure that we have 3y in the middle. Now that means everything gets multiplied by 3, so we would have 15x plus 3y is equal to 63. The second equation, we're not changing anything, so we'll just rewrite that underneath so that we can compare these two and see what we're going to do next. Now the next thing is I look at the symbols in the questions. If the signs or symbols are the same, you subtract the equations. You can remember that by writing SSS, same sign, subtract. If the symbols are different, then you're going to add those equations together. So here we are going to add these equations together, and that gives us 16x is equal to, and we get 72. And not forgetting, we don't need to worry about what 3y add negative 3y is, because the whole point of this is that they're going to cancel out. Now in this question here, we get 16x is equal to 72. Now that's not the nicest of divisions to do, but of course we are using a calculator. So here, where we divide by 16, we're going to divide both sides by 16, and that's going to give us that 1x is equal, and we get 9/2 or 4.5. So we do get a decimal solution for this equation. With simultaneous equations, we also have to find the value of y. So I pick one of the equations that I'm going to substitute this 4.5 into. It doesn't matter which one you choose, but I typically will choose the one that has the positive symbol in, if one of them has a positive symbol. So 5x means 5 times x, which is 5 times 4.5. Again, we can do this on the calculator, so we don't need to worry about the fact that we've got some different or decimal type numbers. That gives us 22.5, and then we'll write the rest of the equation. Plus y is equal to 21. It's a relatively nice equation to solve. We just need to get rid of this 22.5 so that it says y equals, so we'll minus 22.5 from both sides of the equation, and that gives us 1y is equal to, and I'll just type into my calculator 21, take away 22.5, and I get negative 1.5. And there we go, that's my second solution. Typically on a simultaneous equation question, it will have the dotted line that will say x equals ... and y equals ... So just make sure you put them into the correct place on the dotted
So with
lines.
forming and solving equations, there are different types of questions that we can see. We can tend to have questions that have algebraic side lengths or potentially algebraic angles. Now this type of question here actually gives us the perimeter of the shape in a non-algebraic way. So we have the perimeter being equal to 52 centimetres. But on the diagram, all of the lengths, and the perimeter is the distance around the outside, is given to us in terms of algebra. So what we can do is we can add up all of these side lengths, 2x minus 5, x plus 1, x minus 1, and 2x, and set that equal to 52. So if we go round adding the x's up, I'll start with one of them, so 2x, and I'll go clockwise, so 3, 4, 5, 6, so 6x. And we have the numbers negative 5, add 1 is negative 4, take away 1 is back to negative 5, and then we have no number on that bottom piece, so minus 5. Now it tells us that that is equal to 52, and that's how we form our equation. Thinking about another concept here, if those were angles, they would equal 360, because angles in a quadrilateral equal 360. So we don't necessarily have to be given the answer, we could sort of have to know the answer if it's based on an angle fact. So here we can now go about actually solving this. So we can add 5 to both sides. Now when we add 5, we get 6x is equal to 57. Now in this particular equation, we now need to divide by 6. Now that's not going to come out as a nice whole number. So when we divide 57 by 6, ideally we don't want to write it as a fraction. Now if we have a calculator, of course, we can just type that in, so that comes out as 9.5. Now we could give the answer as a fraction if the question had said find the value of x, but this one here says work out the length of DC. Now d to c is the length here, 2x. So if x is equal to 9.5, well then 2x is equal to 2 times 9.5,
and 2 times 9.5 is 19 centimetres. So there we go, that length there is 19 centimetres. And of course we could work out any of the other lengths. We could do the x plus 1, the x minus 1, we'd just use the 9.5 for those as well. But there we go, that is forming and solving an equation with perimeter. With Pythagoras Theorem, we have a formula that we need to know how to use. So Pythagoras Theorem is a squared plus b squared is equal to c squared. And whenever we see a right-angled triangle that doesn't have any angles involved, we should be thinking about Pythagoras Theorem straight away. Now in this circumstance, we are looking for one of the shorter sides. So Pythagoras Theorem is ever so slightly different when looking for a shorter side. In our formula, c is the longest side. So rather than adding the sides together, in fact we have to take the sides away from one another. You can rewrite the formula if you like. You can write c squared take away either of a or b, because we haven't labelled the sides with letters, so it doesn't matter which one we write, we'll just write minus a squared, and that equals the other side squared. So here the longest side is always c, the other two are a and b, however you choose to write them. I'm just going to label the 4 as the a, and then we've got our b down here. So for this one we would do 8.5 squared take away 4 squared. That's going to be equal to the answer that we're looking for, but the answer squared. So if we type that into a calculator, 8.5 squared take away 4 squared, it gives us the answer 56.25. Now clearly that side cannot be 56.25, so this should trigger your memory to remember at this point here you need to square root that answer in order to get to the length that we are looking for. So you just need to type it in. You can use your answer button to speed up a bit of time, but you will get the answer 7.5. That's 7.5 centimetres. Centimetres was already given to you next to the x, so all we would need to say is 7.5 for the value of x. And there we go, that's using Pythagoras Theorem. Now when looking at trigonometry, there's lots of different ways that people are taught this. You may write the ratios down, you may write formula triangles down. Either way is absolutely fine. Now for a formula triangle, as I know a lot of people use this method, if we are looking at SOHCAHTOA, we need to first decide which letters we're going to be using, and they refer to the side lengths. Now this first one here is asking us to work out the length of B to C. B to C is this length down here. That is the opposite side to the angle that we are going to use. The hypotenuse, which is the longest side, has not been given to us, but that means the final side, the 12, is called the adjacent. So here we have the opposite and we have the adjacent. And if we look at our formula triangles, the only one with O and A in is our TOA formula triangle, which means we're going to be using tan. So in this circumstance, you cover up the side that you're looking for, which is the O, and that T next to the A means we need to do a multiplication. Whenever you press sin, cos or tan on your calculator, a bracket will appear, and that reminds you to put the angle in the question into that bracket. Just don't forget to close the bracket. We're going to multiply that by the adjacent, which in this case is the 12, and then we just need to type that into the calculator. So tan 56, not forgetting to close the bracket, multiplied by 12, and that is equal to 17.79. Now there are more decimals, but it does say here to give your answer to 1 decimal place. So I'm going to round the answer from there, which is 17 point. After the 7 is a 9, so the 7 rounds up to an 8. So we have 17.8 centimetres as our final answer. Now for part B here, we are looking at finding the angle. So again, we need to follow the same steps. We need to label the sides. Now this time the side opposite the angle has not been given to us, and it's not the one that we're looking for. So we're just going to label the other two sides. 18 is the hypotenuse and 15 is the adjacent, as it's not the opposite. So we have A and H in this one. A and H is in our CAH formula triangle, which means we're using cos. When you are finding the size of an angle, again we're going to take the same approach. We cover up the C, and that means that we need to do A divided by H. However, if you type in A divided by H, it will just give you a decimal. And you can type it in 15 over 18, and you will see that you just get a decimal, comes out as 5/6, but that is not the angle. In order for the calculator to know that you're looking for an angle and not just doing a division, we have to press Shift cos, which will bring up the inverse of cos. We get cos minus 1. Again, when you type that in, it will open a bracket, and that just reminds you that that fraction needs to go in there. So if we put the fraction in, it would be 15 over 18. You can close the bracket if you like. It doesn't really matter in this particular one because nothing's going after the bracket, but it's always good practice to make sure you do close the bracket so we don't forget in other scenarios. So 15 over 18, and we get the answer 33.557. Again, it only wants my answer to one decimal place. So if we round that to one decimal place, we get 33 point. After the 5 is another 5, so 6. And not forgetting, this is an angle, so that is in degrees. There we go, we get 33.6 degrees as our final answer. When looking at the equation of a line, let's remember that the equation of any line needs to be written in the form y equals mx plus c, unless we would be specifically asked to write it in a different way. Now, finding the value of c, which is the y-intercept, is always dead nice and easy. Of course, we just want to make sure that we don't get the two confused. We don't want to write the y-intercept in the place of the gradient. So here the y-intercept is where it goes through the y-axis, and that's down here at -6. So that would be -6 at the end. We just need to get all the other pieces, and that is just the gradient, which is going to go in front of x there. So to get the gradient, we want to find 2 points that are on the line. Now, we definitely don't want to find completely random points. For example, this one here, we could only estimate the actual numbers. So we want to find points that we can read that are nice whole numbers. There's one just there on the x-axis, and there's another one just here. As well as that, there is another one, obviously down at the y-intercept. You can make this little triangle that I'm about to draw as big as you want, but I'm just going to go across by 1, and then it goes up by 3. And to find the gradient there, you do rise over run, or the change in the y-coordinate divided by the change in the x-coordinate. So here that's 3 divided by 1, which is equal to 3. And that's my gradient. That's going to be y equals 3x minus 6. Just be careful, if the line is sloping downwards, you would take the exact same approach, but the gradient would be negative. So just be really, really careful there. If the line is sloping up, we have a positive gradient, and sloping down, we have a negative gradient. Now, when it comes to reverse mean, it's not always clear and obvious that you're going to be doing reverse mean. There's a lot of information in this question, but it does tell us down the bottom the mean amount of money per person is 80. And when it tells you the mean amount of money per person, or the mean amount of anything per group of people, it means that we can find the total. So if we read this question, it says Jasmine has £65, Kieran has £100, and Samantha has 3 £5 notes, 1 £20 note, and some £10 notes. Now, there are 3 people. So if the mean amount of money per person is 80, then whatever their total is, which we don't know, divided by 3 would have been equal to £80. And this is the process of reverse mean. It's reversing that division that would have happened to find out what that total was. So to reverse this, if we would have divided by 3, we can times both of these by 3 to get our total, and then whatever that total is will be 80 multiplied by 3, which we can do on the calculator, and that was 240. So the total of the amount of money that these 3 people have is £240. Now, Jasmine and Kieran at the moment together have £165. So we can find out how much Samantha has by doing 240 take away 165. Now, I'm going to do this on the calculator, but do notice how I am still writing out the subtraction calculation here to make sure I get my method marks in a question. So Samantha has £75. Now, if we have a look at how much she has at the moment, she has 3 £5 notes, that's £15, 1 £20 note, so £20, and some £10 notes. Well, together, these add up to £35. So in terms of Samantha's money, when we know that she has to have £75, well, £75 take away £35 leaves Samantha with £40. And it says that she has some £10 notes. So clearly you can see, and 10 is a nice number for this, that that's going to be 4 £10 notes,
but of course we could just write divide by 10 and that is equal to 4. So Samantha has 4 £10 notes, which would give her that additional £40, which would make her total be 75 and the total of everybody be 240. And there we go, there is a reverse mean question, thinking about multiplying the mean by the amount of people to get that total. Now, for averages from a table, you could have them as a grouped frequency table, or you could have a fixed number on the left. But if we're asked to work out the mean from a table, we take pretty much the same approach. Except with grouped frequency, we don't actually know the actual, and in this case it's about the time in seconds, we don't actually know the number that's going in that left column. So because we don't know it, we're asked to estimate the mean. And the way that we're going to estimate that is to find the midpoints of the groups. So here we're looking at the midpoint between 5 and 10. Now if you don't know what the midpoint is, you can add those numbers together and divide them by 2. So adding them together is 15, and that gives us 7.5 when we divide it by 2. The next one will be 12.5, then 17.5, and then it's 22.5. Now all we're going to do is multiply across to find the total of each row. So there's one person at 7.5, 2 at 12.5, 7 at 17.5, and 8 times 22.5. So obviously using your calculator for this, and we're going to get the total of each row. 7 times 17.5 is 122.5, and then 8 times 22.5 is 180. Now we know the total of each row, we can get the overall total. So 180 plus 122.5 plus 25 plus 7.5 comes out as an overall total of 335. So to estimate the mean here, we want to divide the total by how many people there are. Now this particular question does tell us up in the words that there were 18 students. However, if it didn't tell us that, we would just add up the total frequency, and that tells us that there's 18 people. So now we can do the total, 335 divided by the 18 people, and we do have a big hint in the question here that we're going to get a decimal number, as it does say to give your answer correct to 3 significant figures. Now this actually comes out as 18.61, and there's a recurring dot above the 1. That just means the 1 carries on forever. So here, if we want it to 3 significant figures, 1 and 8, after that is our third significant figure. It's a 6 and then a 1, so that's going to stay as a 6. And there we go, there is our mean time. And if it didn't say on the dotted line, we would put seconds. And there we go, 18.6 seconds would be our estimated mean. And remembering, we can only estimate the mean here because they are in groups and we don't actually know the exact amount of seconds for each of those people. Now we're looking at a pictogram. It's really important with a pictogram that we have an accurate key. This particular question here says write down one thing that is wrong with this pictogram. Now looking at it, the pictogram is drawn properly and the key is drawn nice and neatly. So there must be something wrong with this key. Now over here we are allowed to use half of a circle. So what does that mean in terms of our key? Well, our key here says a full circle represents 3 CDs. Well, that would mean that half of a circle was equal to 1.5 CDs. Now that's impossible. You can't have 1.5 CDs unless of course you snapped one in half. But as this is about CDs being sold in a shop, of course we're not going to have 1.5 CDs. So we would just write something along the lines of the key here, half of a circle is 1.5 CDs. You can't have 1.5 CDs. And there we go. There is a pictogram, just making sure that you read a key really clearly. And of course, if you have to count how many, in this case, CDs were on a particular day, you would just label each one appropriately and add up your totals. But of course, we can't have 1.5.
Okay, so looking at a quadratic graph. Now, this is another topic where there's a really nice calculator hack that you can use by using table mode on your calculator. I'll link the video in the description because there's some really good calculator hacks in that video where you can basically just type this equation in and it does the whole table for you. Now, if you don't have that type of calculator or you just don't really want to use that method because we need to know how to substitute into this anyway, then I'm going to follow that method.
So here we have x squared minus x minus 6. I always start with a positive number when I'm not using table mode. So for this one here, we're going to do 3 squared minus 3 minus 6, replacing the x with my x value, and then just typing it into the calculator. That one there gives me 0. So that's 9, take away 3, take away 6, which is 9 minus 9. Now I need to work my way through and just do all of those using that method, but of course in the next one, substituting 2 in its place, and I get minus 4. For the next one, 1 squared minus 1 minus 6, that gives me minus 6. Now what you can do to save a bit of time when you use this method is try and spot a pattern. Now I've just spotted side by side, we have 2 negative 6s, which means we have this outwards pattern going from the centre. That's going to be where our sort of turning point is down the bottom, that reflection line down the middle. So on the left of this, we're going to have minus 4, like we do on the right there. To the left of that, we're going to have 0, and you can see that sort of outwards pattern going from in between the negative 6s. So it says in part B, draw this graph. So we need to plot it on very carefully. Now watching me plot points is never the most fun, but I'm going to try and plot them as fast as I can. Negative 2, 0, negative 1, negative 4, 0, negative 6, another negative 6, another negative 4, and another 0. Now a quadratic graph needs to be joined up with a nice smooth curve. So as best as you can, just making sure that they are not straight lines. This method can be applied to all the different graphs as well. So if you're drawing a reciprocal or if you're drawing a cubic, you can use table mode to find those points, but it's just substituting the x values in and drawing it with a nice smooth curve. Part C here says to use the graph to find, this word's important, estimates of the solution to the equation, and then we're given the equation, but it says equals negative 2. Had it said equals 0, we'd be looking at the coordinates where it crosses through the x-axis, but this has said negative 2, so essentially we are dropping the x-axis down by 2 and looking at the solutions where it crosses through this line. Now that's where estimates is important, because obviously all of our graphs are going to be slightly different depending on how we draw our curve, and also we're not computers, so we need to just read these as best as we can. So I'm not going to stress too much about whether it's, let's just find this number. I'm going to go for the one on the right. Now that one there looks like 2.5 to me, but that's, my line's drawn quite thick. Maybe it's 2.4, maybe it's 2.6, but mine is joined up at 2.5. So I'm going to say 2.5. I'm not going to stress too much over it. I've done it as accurately as I can, and I'm going to stick to that number. So negative 1 and negative 2 over there, it looks like just past halfway, so maybe minus 1.6. And there's my two answers. So my two answers would be negative 1.6 and 2.5. And it's normally quite a strange question when it asks this, because it gives you one dotted line, but you've got two answers. And it seems a bit weird writing down two numbers. So just sticking down the word and in the middle of it is absolutely fine. We do have estimates written here, which gives you a little bit of a hint that there's more than one answer. So there we go. Negative 1.6 and 2.5 would be my two estimates for the solutions here, where we're looking through negative 2 rather than at 0. Now a frequency polygon is a really nice graph to draw. Part A here though asks us to find the modal class interval. Now modal class is just another word that's used for the mode when we are looking at groups. So here on the left we have categories 1 to 30 to 140, 140 to 150, and all the rest going down. So for the mode we're looking at which is the most common group. You can see over here there's a frequency of 24 in one of those groups, and that refers to this particular group over here. So the most common, and this is about the height of 80 children, so the most common height or the most common group of heights is 150 to 160, and you just copy down that inequality exactly as it's written in the table. Now this is asking us to draw a frequency polygon. When drawing a frequency polygon, just like when we were finding the mean, we actually use the midpoints. So I want to write the midpoints in. Again, you can use that same approach as before. You can add the numbers together and divide them by 2, but usually it's quite nice to spot those midpoints. From here, I just need to find the midpoints on the graph and plot them on. So 4, and then on the next midpoint we have 11. The next one is 24, The next one is 22. And then we have 19. Now with a frequency polygon, you don't connect this like we did on some of our previous graphs. It's really important with a frequency polygon that these are connected using nice straight lines, which you would use a ruler and a pencil for. So you're going to connect these together using nice straight lines, making sure it definitely doesn't look like a smooth sort of curve or sort of connected not using a straight line. There's not really a phrase that we can use for not connecting it with a straight line, but just make sure that it's really clear that you've joined that up using a straight line. You do not have to connect it to the axes or to the origin, you just need to connect it from the first dot to the last dot, just like that. Now with sampling and bias, you might be given a table that shows a particular sample. This particular question has no table. So it says Millie is planning a school trip for 240 students. She asks a sample of 40 students where they want to go, and then it goes on to tell us that 5 students choose to go to a theme park. Work out how many of the 240 students you think will want to go to a theme park. Now when we're looking at a sample, we just need to know how many chose a particular option, in this case the theme park, and how big was the sample. And we'll write that as a fraction. So in this case, that's 5 out of 40 students wanted to go to the theme park, which means that 5/40ths, or for every 40, 5 want to go to the theme park. Now you can simplify this fraction. Remember, if you type a fraction into your calculator, it will simplify it for you. So if you just type 5/40 in, it simplifies down to 1/8, which means that 1/8 of the students want to go to the theme park. So actually all we need to do is work out 1/8 of 240, which is just dividing by 8. So 240 divided by 8, we can type that into the calculator as well, and 240 divided by 8 is equal to 30 students. And there we go, 30 students want to go to the theme park. Okay, so looking at some pie charts, we have a slightly different question to normal here. Rather than drawing a pie chart, we're looking at interpreting a pie chart. Now it says here the pie chart shows the information about the favourite animal of each student at school A and for each student at school B. It then tells us there are 480 students at school A and 760 students at school B. It says Tamia says the same number of students at each school have tigers as their favourite. Is Tamia correct? Well, in order to find how many people actually like tigers the most, we just want to break down the pie chart and see what 1 degree represents in each pie chart. We can then find out what any amount of degrees represent. So if this pie chart over here on the left, School A is 480 students, and of course 760 on the right, we want to find out exactly how much is in each sector. So if we divide each of these by 360, and we'll start with School A, 480 divided by 360 is 4/3. Not the nicest of numbers, but 1 degree is equal to 4/3. That's fine, I'll just leave it as a fraction for the moment. We can now multiply that by 60, and that will tell us the amount here that liked monkeys the most. So if we times by 60, that is 80 people. So 4/3 times 60 gives us that 60 degrees is 80. So 80 people like monkeys the most. Now there are 480 people in total at this school, and 480 take away 80 is 400. Now both the lions and the tigers here are both X, which means that they're both the same. So if there are 400 in total, if we divide this by 2, that tells us that each of those represents 200 people. So the lions is 200 people and the tigers is 200. We now know how many people preferred tigers at school A, so we're just going to have a look at school B. Now as it turns out, in school B this is actually a 90-degree angle, and a 90-degree angle is a very nice one because that's 1/4 of the circle. So we could actually just divide by 4 to see that amount of people in that particular sector. However, we can take the same approach. You could do 760 divided by 360 to find out what that represents, but as it's 90 degrees, we should always look for ways of saving time, so we can actually just do 760 divided by 4, which is 1/4,
And if we type that in on our calculator, we get 190. So that's 190 in this particular pie chart. We don't need to find the other two because we are only comparing the tigers. So here it says, is Tamia correct? She said the same number of students at each school have tigers as their favourite, but we've just identified that school A was 200 and school B was 190. So we would say no, Tamia is not correct. There we go. So Tamia is not correct. And we have our numbers to back that up. You could write in a little sentence, tigers are 200 at school A and it's 190 at school B.
Okay, so looking at tally and bar charts. So it says Mrs. Brown asked each child in her class which pet they like best, and here are her results. It says complete the frequency table for this information, and on the grid draw a bar chart for this. So when we are filling this out, we'll go through the tally, and as we do each tally, we'll cross it off in the list. So I'm going to go through, I'm going to try and find all the dogs. Let's have a look. So 1, 2, 3 more there. Here's another one. I normally miss one as I go, so we'll see when we sort of get through this whether we miss any. And that looks like all of them. We then have the rabbit. So there is 1, 2, and another one here. And then let's just go for a few cats. Here we go. So 2 of those, another 2, 3 there. So 1, 2, 3. Crossing that off when we get to 5. And then we have 1, 2 hamster. And there we go. Double check. Make sure you've definitely crossed them all off. And then we can put our frequency in. So for dog, we have 8. For rabbit, we have 3. Cat, we have 5. And hamster, we have 2. When we want to draw a bar chart for this, we now know the highest number that this needs to go up to. So we want to check our scale, which obviously is going to start at 0. And we want to think about if we can fit this in sort of as large as we can up the graph. So if I was to go 1, 2, 3, 4, 5, that's not going to fit everything in. So we're going to have to go up in 2s there, or up every 1 for every square. So that's going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Down the bottom, we can now draw our bars in. So I'm going to leave a gap, and I'm going to draw my first bar, which is going to go up to 8. And we're going to label that down the bottom, dog. Then we'll go for rabbit, leaving the same gap between each bar here. So up to 3, we'll label that rabbit. And then the next one, we're going to go up to 5. And that is cat. And the last one, up to 2. And there we go, that one is hamster. We are also given another question here that says write down the most popular pet, and that is the highest bar, so that will be dog. And there we go, that is completing a tally chart and then using that as well to draw a bar chart.
Now these questions where we are converting both currency and units are always questions that just don't look very nice to answer. There's a lot of numbers going on. We've got one thing in euros, one thing in pounds, one in litres, one in gallons. But ultimately, all we need to do is get everything into the same currency so that we can make a comparison in terms of the value. And we also need both of them to be in the same units. Now, it makes sense to convert the currency into pounds, as that's the home currency of what we are using. So here, we're going to first change the 54 euros into pounds. Now, you can see in the pounds to euros conversion here that the pound number, the size of the number, is smaller than the euro number. They have the same value, but it's a smaller number. So in order to get the 54 euros to become pounds, we either need to multiply or divide by 0.85. But having an awareness that the number has to be smaller means that at least if we do the incorrect one, then we're going to know about it. So the correct method here is to do 54 multiplied by 0.85. That gives us that smaller number, which we'll see now. And we get £49, £45 and 90 pence. So that is the cost of the 36 litres. Now, it doesn't really matter whether we make a comparison in litres or in gallons, but I can straight away find a value now for this petrol. So here it's £45.90 for 36, and I'll just put L for litres. Now we don't want to compare the price at 36 litres, we want to know what the value of 1 litre is. So to get there, we just divide by 36, so £45.90 on the calculator, divide by 36, it is 1.275, or £1.27 and a little bit extra. I'll leave the 5 in there just in case our next one comes out as £1.27 with a little bit extra as well, just in case they're really close. So for the next one, it's already in pounds. We have £81.60 for, at the moment, 16 gallons. Now it tells us here that each gallon is 4.5 litres. So I can actually turn this into litres relatively easily. I just need to do 16 multiplied by 4.5, and that's going to give it me in litres, as every 1 gallon is 4.5 litres. So 16 times 4.5 is 72 litres, and now we have a comparable sort of unit. So we have £81.60 for 72 litres, and again we don't want to compare the value of 72 litres, so we could divide by 72, and £81.60 on the calculator divided by 72 comes out as £1.13. There is a recurring dot above the 3. It doesn't really matter if we put that in, because ultimately we can see that this one is cheaper. Per litre it's £1.13 rather than £1.27, regardless of those sort of sub-pennies after that. So there we go, it is cheaper in that second option, and that was in Scotland. Now, it said here, Olivia thinks that petrol is cheaper in France than in Scotland, but we've just showed that it's actually cheaper in Scotland. So is Olivia correct? We would just say no, Olivia is not correct. And we have all of our working out. To back that up, you could write after that actually it is cheaper in Scotland. And there we go, that is some currency conversions, but also dealing with different units. When looking at a conversion graph, the obvious conversions here could be absolutely anything. This one is about hours worked and pay, so it's not really a conversion graph here. This is more of a real life graph, but it's going to be treated in exactly the same way as a conversion graph. So we just looked at some currency conversions, so this is just something a little bit different. You might have a conversion graph where on the left or the y-axis you have pounds, and on the x-axis maybe we have euros. We're going to treat it in exactly the same way. So this is more of a real life graph where it's showing how much pay you get for a certain amount of hours. It says here, how much is Jack paid for each hour that he works? Now it doesn't really matter exactly where we go up from, but I would have a look on the left of the axes there to see if any of the 1, 2, 3, 4 or 5 hours lands on a nice number. Now I've just spotted as I go up from 1, that doesn't really land on the nicest of numbers. Now you might argue that that's quite clearly in the middle, but actually going up from 2 lands on a really nice whole number there. It lands on 30. So it doesn't really matter which one you use, but we do get therefore £15 for 1 hour. So our final answer is £15. If you went for the 2 hours though, you could divide £30 by 2, again, which would get you to 15. Part B here says last week Jack worked for 36 hours. How much was Jack paid? Now, unfortunately, we don't have a number on the graph here, which is 36, so we can't read it straight off the graph. However, we can use any of the numbers to actually get to 36. Now, as we know he was paid £15 for 1 hour, we could actually just multiply that by 36. But we could take any approach. We could go across from the 2, which was £30, and times that by 18. 2 times 18 being 36. We could get the 3 hours and times it by 12. We could get the 4 hours and times it by 9. There's lots of different ways of doing this. As we've got the 1 hour and it was easy to read, it makes sense to just do £15 multiplied by 36. So on the calculator, 15 times 36, that gives us £540. So Jack was paid £540 for his 36 hours. Now in this question, we are looking at some simple interest. It says here, Ryan invests £1,000 for 5 years in a savings account. By the end of the 5 years, he had received a total of £125 simple interest. Work out the annual rate of simple interest. Now, in a question like this, simple interest is the nice one. It means that you only get the same amount of interest every single year. So if something is simple interest and it's 5 years, it means that this amount of interest here is just 5 times each amount he got each year. So I can just do 125 divided by 5, and that comes out as £25. So each year, and I can put per year after that, he got £25. And it wants to know what that is as an annual rate of interest. Well, if you put £1,000 into account, there's a few ways that we could work out exactly what that is as a percentage. Now, it's more of a non-calculator approach, but we could just think about some different percentages, which I do quite like as a method even with a calculator. 10% would be £100. 5%, because we need to go smaller, would be £50. We're getting pretty close, and you can probably see the link now that if we halve that again, which would give us 2.5%, that is equal to £25. So actually the annual rate of interest is 2.5%. So that's one method that you could use. You could also write it as a fraction. So what is 25 out of 1,000? That'll give us it as a decimal. If it's going to give it us as a decimal, you just need to times by 100. So when you do that, you'll see it just straight away comes out as 2.5%. That is a slightly more advanced method, knowing how to use it as obviously with a calculator method there, but that is how you find a percentage. 25 out of 1,000. It's a good one to think about if you've ever given yourself a percentage on a test. You'll know that you write your score out of the total and then times it by 100. Now our next question is looking at compound interest, and compound interest is a little bit more complicated. However, we can use the calculator really effectively for this. So it says Emily wants to invest £25,000 for 3 years in a bank. In the personal bank, she gets compound interest of 2% per year, and in secure bank, she gets 4.3% in the first year, but then only gets 0.9% for each additional year. Which bank will give Emily the most interest at the end of 3 years? Now, when you are dealing with compound interest, all we need to do is figure out the multiplier that we need. Now, to figure out the multiplier, essentially, we add the percentage that we've been given to 100%. So 100 plus 2 means that each year it's 102%. Now, as a multiplier, all we have to do is turn that into the decimal version, which is just dividing by 100. So it's 1.02. And that's what we have to multiply by to increase by 2%. So in this question here, for personal bank, we start with £25,000. We have to multiply by 1.02. And that will do 1 year. From there, you could write it down and then multiply by 1.02 again to find year 2, write it down, and multiply by 1.02 again, and write it down, and you'll have your 3rd year. However, you can get around that by just doing the power for the amount of years, and that'll just multiply by 1.02 3 times and do it all for you in one jump. So 25,000 times 1.02 to the power of 3, that comes out as £26,530 and 20 pence. So that's how much she'll get if she invests in personal bank. Now we do need to be a little bit more careful with secure bank because there is a different amount in the first year. And with 4.3%, we do get some quite small percentages in terms of the multiplier. So if we add that to 100%, in this question, you would get 104.3% in the first year. To turn it into a multiplier, divide by 100, and just being really careful of those decimal places, we get 1.043. So in the first year, we need to times by 1.043. So 25,000 multiplied by 1.043. I only get that in the first year, so I am going to have to write that down this time. 25,000 times 1.043 gives me £26,075. Now that is now how much Emily has in the bank, £26,075, and we're going to have to multiply that by the new multiplier for the 0.9% that you get in every extra year. So adding that to 100 wouldn't be much over, it'd be 100.043. 9%. And that's all that we're going to get in that second and third year. Again, dividing that by 100, which is being really careful now, because we do get 1.009, and that's what we're going to have to multiply by. Now you've got two options again. You can multiply by 1.009, write it down and do it again, but I'm going to put a power of 2 with this one for the 2 additional years. So 26,075 times 1.009, and then that is to the power of 2, and that comes out as 26,546 pounds and 46 pence. So you can see here, actually, we get slightly more in the secure bank. Not much more, it's about £16 and 26 pence. So we would just say here which bank will ever get the most interest. So we want to make sure that we write down somewhere near our working out secure bank. And you could write some more with that. If you prefer, you could write secure bank will give Emily the most interest. But just make sure it's really nice and clear which one we're choosing. Okay, so in this question, we are looking at a reverse percentage. So it says here the value of Michelle's car had decreased by 15%. The car now has a value of 13,600. Work out the value of Michelle's car before the decrease. So there's a lot of language here that gives you the hint that it is a reverse percentage because we're given the value after the decrease and it wants it before the decrease. So when we're looking at a reverse percentage, lots of different ways that you can do this, but a nice visual way of thinking about it is a bar model. If this is the 100% original cost of the car and it's decreased by 15%, 15% has been taken off. Now out of that original 100%, that leaves us with 85%. So these are the two percentages that you can be given. Either they've told us the 15% it's decreased by, or they might tell us the value after the decrease, which is the 85%. Now this question does say the car now has a value of 13,600, which is the 85%. So 85% is equal to 13,600. We want to get back to the original 100%, and because we're using a calculator for this, we can divide down to 1%. So we can do that by dividing by 85 and then just timesing by 100, and that's going to get us to that original 100%. We can type that in the calculator. So divide by 85 gives us £160, and then times by 100, and that gives us £16,000, and that is our final answer there, £16,000. Now you can also be told that something has gone up in value, and if it's gone up in value, it might be that the percentage you are given is more than 100%. For example, if it had increased by 15% and the car now had a value of 13,600, that would be 115%. We would divide by 115 and then times by 100. But there we go, there is a reverse percentage. Okay, so looking at a reverse mean, also sometimes called a combined mean, because we're looking at the mean of more than one thing. So it says here there are 25 girls and 15 boys in a class. The mean score for all 40 is 68. The mean score for the 15 boys is 74. Work out the mean score of the 25 girls. Now, again, with a question like this, think about if we had the information, what do we actually need to work out the mean score of the 25 girls? We need their total score, and we would then divide it by 25. So we are missing their total. So what we can do is we can use the mean given to us for the whole class and for the boys to work out their totals, and the girls' total will be what's left over. So 40 students that have a mean of 68, we would have taken their total, let's call it X, we would have divided by 40 and we'd have got 68. So in order to work out their total, we just need to multiply 68 by 40. So 68 times 40, I'm going to type that in on the calculator, gives me a total of 2,720, and that's for all of them. So you can either label that with whatever writing you want, but just remember that is an important number there. That's the total of everybody. I can now apply the exact same to the boys. Now I'm going to write a different letter down because I don't want to get confused with the fact that this is now a different number. So we have y divided by 15 boys gives me a total of 74.
Same process, I'm just going to divide times by whatever I would have divided by to get that mean. So times by 15, and we get the total 74 times 15 for the boys, and that is 1,110, and I can label that boys. So for this now, in order to get the total for the girls, I would want to take the total for the whole class, 2,720, subtract 1,110. Don't actually need to do that using column subtraction, but I want to make sure my working out is nice and clear, particularly just in case I have made a mistake. I'm still going to get those method marks for doing the correct process. So the total score for the girls is 1,610. And it even tells us in the last line here, there are 25 girls. So I want to divide that by 25. I'm going to do that on the calculator, and it will give me their mean, which does come out as a decimal, which is 64.4, and that is the mean score for the girls. So there we go, that was a reverse mean, also sometimes called a combined mean, where we're looking at different means that are given to us in one question.
So looking at a distance time graph. It says here Brandon drives his car on a journey. Here is the travel graph for the first 15 minutes. Work out Brandon's speed in kilometres per hour for the first 15 minutes. Now, it might be that you want to use your speed distance time formula. However, you might not necessarily need to. It's already told us that this is 15 minutes, and we can see that it's between 10:10 and 10:20. So that particular journey is 15 minutes. So it's taken him 15 minutes to go 20 kilometres. Now, if you wanted to, with speed distance time, you could now convert the minutes into hours by writing it as 15 over 60 and using your formula. But in this particular question, we actually just need to get to 60 minutes. We want to know a speed, and normally we would give a speed in kilometres per hour. So to get to 60 minutes, all we need to do is multiply by 4. And you can do that on your calculator. 60 divided by 15 is 4. So all we would need to do is times by 4. And that means we would go 80 kilometres in 60 minutes. And there we go. So our speed in that first 15 minutes is 80 kilometres per hour. And there we go. That'll be our final answer for part A. It says at 10:15, Brandon stops for 10 minutes and then drives for 20 minutes at a speed of 75 kilometres per hour. On the grid, complete the travel graph for Brandon's journey. Well, if he stops for 10 minutes, well, each of these lines going across is 5, so that's 5 minutes, and then another 5 minutes. So that means we get to here. And then he drives for 20 minutes at a speed of 75 kilometres per hour. Now, it doesn't say that he drives home, it says he continues driving. So our distance time graph is going to keep going upwards. Or in other words, it's going to sort of keep going up to here somewhere. We just need to figure out exactly where it's going to go. So, 20 minutes at a speed of 75 kilometres per hour. Now, there are different ways that you could approach this. We could think about approaching it in terms of a formula, like we've done before. So, speed, distance, time, we could use a formula triangle. If you prefer, let's have a look. And we want to know a distance. We have a time and we have a speed, and we want to know a distance. So all we have to do is multiply these two pieces together. Now the speed is 75, however, and this is why I prefer the method I used above, because now I need to multiply by 20 minutes, but it needs to be in hours. That's not difficult for us to do, it's just 20 out of 60. But in the moment of an exam, you've got to remember to do that. So it's 75 times 20 over 60. If we times by 20, hopefully it would trigger through to you there that that's far too much, because 75 times 20 would give us a distance of 1,500 kilometres. And that obviously goes way off our graph. So we're doing 75 times 20 over 60. If we type that in, that comes out as 25 kilometres. So Brandon does 25 kilometres in the 20 minutes. You could think about this in lots of different ways though. That is 1/3 of an hour. So if it's 1/3 of an hour and he does 75 kilometres per hour, well, 1/3 of that is 25. So lots of different ways that you can think about these questions. So in 20 minutes, let's figure out how far along that goes. Well, each line is 5. So if we sort of imagine 1, 2, 3, 4, that gets us 20 minutes across. It just needs to go 25 kilometres up. We're currently at 20, so we need to go up to 45, which is just here. And there we go. So if we connect this up now, that's 20 minutes later. And just double check that. We're on 25, we get to 45. And therefore, there we go. That is where our graph is going to finish. So a nice straight line joining that up. And there is our distance time graph.
Okay, so if you've ever sat any past papers or practiced any past papers, which I'm sure that you have, you'll recognise questions like this. Lots of words, fractions, ratios, sometimes percentages involved. So we need to go step by step through questions like these. First, read it through, figure out what it's asking you to do, and then just go step by step from the top. So this one just says, Maya's got 600 balloons, 2/5 of them are inflated. For the inflated balloons, red to blue is 2 to 3, blue to green is 6 to 5. We want to work out the percentage of Maya's balloons that are inflated red balloons. And it says give your answer to one decimal place, so we know our percentage is going to be a point something. So first of all, we can work out this 2/5 of 600 to see how many are inflated. So on my calculator, 600 divided by 5 is 120. So 1/5 is 120, and therefore 2/5 is double that, 240. Now numbers like that are really important. So make sure you underline them, make sure they're nice and clear so you don't get lost along the way. Even if you want to label that and just write, this is the inflated balloons, might just make sure that you keep using the correct numbers along the way. For the inflated balloons, red to blue is 2 to 3, and blue to green is 6 to 5. Now what should stand out straight away when there's two ratios is that blue is in both. But blue has a different number in both. In this one it's 3 and in this one it's 6. So what we need to do is find the lowest common multiple of those. And in this case we only need to change the top ratio, because if we times the top ratio by 2, that will become 4 to 6. And now we have the same number representing blue. So as a 3-part ratio, red, blue and green, we have 4 representing red, which we've just changed, 6 representing blue, which is now the same in both, and 5 representing green. So for these inflated balloons, we know that they are in the ratio 4, 6, 5, which is a total of 15. So we can find out how many of each colour there are. So like we would do with any normal ratio, we'll divide the total by the amount of parts. So 240 divided by 15, just doing that on my calculator, which is 16 per part. So I can multiply all of these numbers by 16. So 16 times 4, and that is 64. We have 6 times the 16 as well, 96 blue, and 5 times 16, which is 80. Now I might not actually need all of them, and in this question I actually don't. It says work out the percentage that are inflated red balloons. So I only really care about these 64 red balloons. Now we have 64 inflated red balloons, but what it's asking me to make it a percentage of is really important. Here it says work out the percentage of Maya's balloons. Now it could have phrased that in two different ways. It could have said the percentage of Maya's inflated balloons, which would have been out of 240, because we have 240 inflated balloons. This one though, it says Maya's balloons. Well, she has 600 balloons. So as a fraction of that 600, we have 64 out of 600 that are inflated red balloons. If we type that in on the calculator, 64 over 600, we get a decimal, 0.106 recurring. To turn that to a percentage, we just times by 100. So times by 100, and our percentage is 10.6 recurring percent. Now it wants this to one decimal place. Typically, if you click your calculator, it'll turn this recurring dot into lots of sixes there anyway, but we want to chop it to, or round it to, one decimal place, which will give us 10.8 10.7, because after the 6 is, of course, another 6. So 10.7%, and that would be our final answer. There are 10.7% of Maya's balloons which are red inflated balloons. So there we go, working through that question step by step. We had fractions, we had ratios, and we had some percentages there at the end.
So this next question is looking at density, mass and volume, and this one here actually gives us a prism that needs us to work out the volume of. It says the prism is made from wood with a density of 0.8 grams per centimetre cubed. Work out the mass of the prism. So our formula for density, and again you can use a formula triangle, density is equal to mass divided by volume. So here we're working out a mass. So to get a mass we do the density multiplied by the volume. We're given the density in the question, but we're not given the volume. But of course we're given the shape and it wants us to work out that volume. To get the volume of any prism, you work out the area of the cross section, which is the shape that passes all the way through the shape. In this case a triangle goes all the way through. And then we're going to times it by the length. And in this case the length is 10. So we need to know how to work out the area of a triangle, which is base times height divided by 2. So here the base is 4, the height is 6, and we're going to divide that by 2. That is equal to 12. So the area of the cross section is 12. To get the volume, you take the area of the cross section and you multiply it by the length that it goes through the shape. So 12 times 10 gives us a volume of 120 centimetres cubed. Now with all density questions, you do need to make sure before we use it in our formula that our units match. And in this question, we do have centimetre cubed in our density units there. So we already established we're going to do the density times the volume as we're working out the mass. So 0.8 being the density multiplied by 120, which is the volume that we've calculated, and 0.8 times 120 is 96. Now the units for the mass are also in the question. We're told grams here, so we know that the mass is in grams. And there we go, 96 grams is our final answer. Okay, so in this question we're looking at pressure, force and area. It says here a force of 70 newtons acts on an area of 20 centimetres squared. And we are given the pressure is equal to force divided by area formula. It says the force is increased by 10 newtons and the area is increased by 10 centimetres squared. Tau says the pressure decreases by less than 20%. Is Tau correct? Well, let's have a look. So if we start off by using our initial numbers, we have a force of 70 and an area of 20. And we can type that in on our calculator. 70 divided by 20 gives us 3.5. So there we go, that's our initial amount. Now in the second amount, it says the force is increased by 10 newtons. So we have 80 newtons now on the top. The area is increased by 10. So that would be 30 centimetres squared. And we can work that out. So 80 divided by 30. Again on the calculator, we do get a recurring decimal for this one. It comes out as 2.6 recurring. So these are our two values. It says Tau says the pressure decreases by less than 20%. So let's just have a look. Decreases by less than 20%. So if we work out 10% of the pressure up here, 3.5, and then double that, or just work out 20%, and subtract that from 3.5, we can compare it to this 2.6 recurring, and then we'll decide if it's more or less. Now with a calculator, you can of course just work out 1%. I'm going to work out 10%. So 10% is 0.35. 20% will be double that, 0.7. So 20% is 0.7. Now if we do 3.5, subtract 0.7, and again we could just do this on a calculator just to make sure we get everything correct, that comes out as 2.8. So clearly they are different right now. So the pressure decreases by less than 20%. Well, if we decrease it by 20%, it goes down to 2.8. This has gone down to less than 2.8. It's gone all the way down to 2.6 recurring. So actually, no, Tau's wrong, it decreases by more than 20%. So is Tau correct? No. You could say it decreases by more than 20%. There you go, by more than 20%. We don't need to say what the exact percentage is. It doesn't ask us that, it just says is he correct or not. We've done the working out, we've shown that it decreases by more than 20%, so it's fine just to make that statement. Okay, so for sharing in a ratio. This question says Alex, Priya and Jordan share some money in the ratio 3:4:2 and Priya gets £120. Now to be fair, before we even carry on, we could work out now how much everybody else gets, because the money that Priya gets is going to go underneath the 4. So that's going to be 120. Now we'll carry on reading through the question, but we're going to need to come back to that. So it says Alex then gives some of his share to Priya and some to Jordan, and the money they now have is in the ratio 2:5:3. How much money did Alex give to Jordan? So Jordan is the number at the end, so we'll figure out how much money they actually shared. We'll split it back up into this new ratio, and we'll see how much he actually gave to Jordan. So here we know to get from 4 to 120, we need to figure out what to divide by, or what we've multiplied by. So we can divide 120 by 4, which is 30. So all of these are getting multiplied by 30. So the 2 becomes 60, the 3 becomes 90. So we can now go ahead and add these together. So 90 plus 120 plus 60, and that adds up to 270. And in this particular scenario, Jordan had £60 and Alex had £90. So when we look at how much money did Alex give to Jordan, we want to look at how those numbers changed. So in the new ratio, we have £270, and that's getting split up in the ratio 2:5:3. Now in total, there are 10 parts. So 270 divided by 10 is equal to 27. So we want to multiply all of these numbers by 27. So 27 times 2 gives us 54. 27 times 5 gives us 135. And 27 times 3 gives us 81. So we're going to look in at either how much money Alex gave away to the other two and do them separately, or for this one, as we want to know how much money Jordan was given, we can just have a look at how much money Jordan went up to. So Jordan went from 60 down to 81, so our total there would be 81 minus 60, and that is equal to £21. So obviously a question like this, where you have two separate ratios, but it is just sharing in a ratio. But we had a whole story going on, and in this particular example, we had this scenario where we were told one of the numbers in the ratio. So Priya was equal to 120. But of course, you could be told the total, you could be told the difference between two of them originally. And all of those, you just need to be careful with the language in terms of how to approach it. But there we go, that was a question on sharing in a ratio. Okay, so in this question we have some angles involved, but we also have some ratios involved within these angles. So this particular one focuses on a triangle, but of course this could be involved in any type of shape. Now we know that a triangle, the angles add up to 180 degrees. Now here we actually have sort of two triangles that have been put together, but we have this large triangle around the outside and we are missing that bottom right angle. But it tells us in the question that the size of angle DCB, which is this one here, to the size of angle ACD, this little one here, is in the ratio 2:1. Now that could be written as algebra. You could write it as 2x and 1x, however you prefer to look at it. Or of course we could figure out what angle we are missing and just share it in a ratio like we normally would. So this is a relatively nice one in the sense that we can just add together the 51 and the 75, which gives us the total of the angles within the triangle that's given to us currently. So that's 126. We can then take that away from 180. So 180 minus 126, obviously showing all of our working out, is equal to 54. So we could now share that in the ratio 2:1. Or I could treat it with algebra, which I'd do in the same way. We'd have 3x is equal to 54, and we divide by 3 just like we would if we were sharing in a ratio. So 54 divided by 3 gives us that x is equal to 18. We now just need to apply that to the correct angle. So BDC is the angle that we're looking for. Well, this angle here is 18, 2x just below is 36, and now we can actually look for the angle BDC. So BDC is within this sort of secondary smaller triangle down below, and BDC is the angle in the top there. We have 51, add the 36, in total that gives us 87, and we want to take that again away from 180 to find that missing angle within the triangle. So 180 minus 87 leaves us with a 93 degree angle that's missing at the top there. So there we go, that is 93 degrees. Now we've got a slightly harder problem here, as we have a right-angled triangle connected to a circle sector. It's a relatively nice circle sector because you can see we do have a right angle here, which I'll label, which means it's 1/4 of a circle. So nice circle sector. It says the right-angled triangle ABC has an angle of 90, which we can see there, 90 here as well. And the quarter circle has centre C and radius CB. Work out the area of the quarter circle and give your answer to 3 significant figures. Now, in order to work out the area of any circle or circle sector, we need to know the radius. And the radius here is connected in between the sector and the triangle. So, although we've already looked at this topic, this is actually involving Pythagoras. And it's another Pythagoras question where we're looking for the shorter side. So with Pythagoras, we're going to square both the sides. When finding a shorter side, we subtract them. So 9 squared take away 6 squared. We can write that down to start with. We then have to square root our answer. So that does come out as 45. To get that length, we need to square root 45. And if we do the square root of 45, we do get a decimal here, although it did say to give your answer to 3 significant figures. So we know there's going to be decimals involved. 6.708203. There are a few more decimals, and feel free to write them all down. However, I have written down 7 significant figures there, so I shouldn't have any rounding errors as I've gone way beyond 3. Now, we need to know how to work out the area of the circle sector. So when working out the area of a circle, we have our formula. The area of a circle is equal to pi r squared. Well, we now know the radius. This is r. So this is our radius here. So we just need to put that into our formula. So for the area, we'll do pi multiplied by that number there squared. I'll put it in brackets as it's quite a long number. That squared's going to look a little bit strange at the end of it. So 708,203 squared. And we'll work that out. I'm going to use the full number as it's still on my calculator. But it would be absolutely fine just to use that rounded version in this question. Now that comes out as 45 pi, or as a decimal, 141.3716694. Now, as it is a quarter circle and not a full circle, we do need to account for that. So for a quarter circle, we would just divide by 4. And if we divide this answer by 4, that will give us the area of the quarter circle. So dividing that by 4, and I'll have to write it over here, we get 35.34291735. It wants the answer to 3 significant figures, so I will chop it after that third number there, and that is 35.3. And don't forget, this is an area, it's in metres, so it would be metres squared. Of course, the dotted line on your exam might say metre squared on it, but do check. If it doesn't, you are going to get a mark for writing the correct units. But there we go, there was a question looking at Pythagoras to find the radius, and then using area of a circle with a circle sector as well, so having to divide our answer by 4. Now this question here looks way more complicated than it actually is. It is a tricky question, but it definitely looks more complicated than it actually is. And that's because of this bit down here. It says show that x is equal to the square root of k pi, where k is an integer. Now let's just see what we can do, and you'll see that actually this isn't too bad. It says the diagram shows a cube with edges of length x and a sphere of radius 3, and it gives us the formula for the surface area of a sphere. The surface area of the cube is equal to the surface area of the sphere, and then it wants us to show that. Well, where it says the surface area is equal to, that means if we get the surface area of the cube, we'll just put an equal sign and then put the surface area of the sphere. Now the cube, of course, has algebra on there, so it is a tricky one to get the surface area of. But in this question here, there's a really easy mark just for getting the surface area of the sphere. Because all we have to do is put 3 into that formula. So over here, if we put 3 into the formula, we get 4 times pi, just using this formula here, times the radius squared, so times 3 squared. And of course, that's just typing it into a calculator. In fact, you don't even need to type this into a calculator because that's 4 times 9. Remember, 3 squared is just 9. 4 times 9 is 36, so you can just leave it as 36 pi. And actually, the question does want a pi symbol in the answer. So actually, there's a big hint there that we don't even need to type this into a calculator. But 4 times 3 squared is 36. That's part of it done. Now the cube has side length of x, and all of the sides are equal to x. Now if you want to work out the area of just one face, let's just look at this one on the top, and that is a square with side lengths of x. Well, that face would just be x squared. X times x is x squared, and that's the area of the face. Now a cube has 6 faces. So if one face is 1x squared, then all 6 faces would be 6x squared. And that is the surface area of the cube. There we go, just taking our x squared and multiplying it by 6. So we now have the surface area of the cube, 6x squared, and the surface area of the sphere, 36 pi. And it wants it to say x equals. So actually the first thing that we need to do is actually just sort of solve this as if it was an equation. That kind of is an equation, it's just that we have a pi symbol there. So to start with, we want to divide by 6. Just like we would if it was 6x equals 36, we would just divide by 6. When we do that, we get x squared is equal to 36 divided by 6 is 6, so 6 pi. And you can probably see that we're basically done now. To get rid of the squared, we're going to need to square root, and we'll square root the other side, and we get x is equal to the square root of 6 pi. And there we go, we've got our final answer. X is equal to the square root of 6 pi. So there we go, k is equal to 6. It doesn't ask us to say what k is equal to, just wanted us to show that x was equal to the square root of something pi. We found that it was 6 pi. And there we go, there's our final answer. Definitely a tricky question, but not as bad as it looks. Now when we are looking at similar shapes, when you see that word similar, it means that one shape is an enlargement of the other. Now here both of the shapes are drawn in the same orientation, and you can see that via these little bits that are labelled on the angles. It tells us that's the same angle as on the other diagram. So before we even think about how to find any missing lengths, we need to identify what the scale factor is between them, which means we need to identify a similar side on both, or the same side on both, that has actually been given. So you can see on the left we've been given 8.4, and in the same position on the right we've been given 12.6. So to find what it's been multiplied by, we just need to do the bigger length, 12.6, divided by the corresponding smaller length, 8.4. That's going to give us the scale factor. So 12.6 divided by 8.4 comes out as 1.5. Now that is our scale factor. That means to get to the right triangle, the bigger triangle, we would multiply by 1.5. And to get to the smaller triangle, we have to divide by 1.5. So now we're just going to apply that. Work out the length of DF. Well, that's going from the smaller triangle up to the big one just here. To do that, we would do 6.4 multiplied by 1.5. And just make sure you use your calculator to get this right. And that comes out as 9.6. So there we go. That would be 9.6 centimetres. For the other part of the triangle, it says work out the length of C to B. Now that is going from the 15 back to the smaller triangle. So we would divide by 1.5. And we're doing 15 divided by 1.5. 15 divided by 1.5 is 10. So our answer for that would be 10 centimetres. So there we go, regardless of the diagram, do the bigger shape divided by the smaller shape, and just make sure you match up that corresponding length. And if you are given the diagram, and the diagram is drawn inside of one another, in this sense here, so if we have the larger triangle on the outside, and they draw the smaller triangle on the inside, which this one could have been drawn like this, something like that, then just remember to split those shapes up and draw them separately, like they've done in this diagram. But there we go, that's some similar shapes. Okay, so this question is looking at a cylinder. It says here, Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 and height 160. The 4 tanks are going to be filled completely with a mixture of fertiliser and water. The fertiliser has to be mixed with water in the ratio 1 to 100 by volume. Karina has 32 litres of fertiliser. And it tells us here that 1 litre is equal to 1,000 centimetre cubed. Has Karina enough fertiliser for the 4 tanks? You must show how you get your answer. Well, for starters, we need to actually work out the volume of one of these cylinders. So the volume of a cylinder is the same as any other prism. You get the area of the cross-section and times it by the height. Now the area of the cross-section here is a circle, so we need to get the area of this circle. To do that, we want to know what the radius is. The radius is half of the diameter, so that's going to be 40 centimetres, and then we're going to use our formula pi r squared. Once we've done that, we'll times it by the height, and that's the volume of the cylinder. So if we work that out, that's going to be pi times 40 squared, and we can either type that in and then times by 160, or we can just times by 160 straight away. And let's just write that down then. So pi times 40 squared times 160, and that gives us a very large volume here, but we get 804,247.7193. And there we go, that is the volume of one tank, 804,247.7193 centimetres cubed. Now it says here that we are going to have 4 tanks. Well, she has 4 tanks, so we need to multiply this by 4. That's going to give us the volume of all 4. So if we press times 4 on the calculator, we're starting to get to some very large numbers now. That's absolutely fine though, just make sure we write them all down. So we have 321,6990.877. So that's 3.2 million centimetre cubed. Right, so we're getting some very large numbers. Now, it says here, Karina has 32 litres of fertiliser, and it's going to be mixed in the ratio with water 1 to 100. So we're going to need to work out exactly how much volume we have here, but that's given to us in litres, and we're currently working in centimetre cubed. So completely up to you. You could either convert the 32 litres into centimetre cubed and keep dealing with very large numbers, or we could turn this volume now into litres, and we can do that just by dividing by 1,000, as it's 1 litre for 1,000 centimetre cubed. So if we divide that by 1,000, at least we're going to get some slightly smaller numbers. So here in litres now, the 4 tanks is 3,216.990877, and that's now in litres. So that's how much space is in those 4 tanks. We just now need to work out exactly how much space we actually need. So the fertiliser is to be mixed with water in the ratio 1 to 100. So the fertiliser to the water is 1 to 100. Karina has 32 litres of fertiliser. So she has 32 litres, so we need to multiply by 32, which means we're going to have 3,200 litres of water. And the total there, if we add those two together, is 3,232 litres. So, has Karina enough fertiliser for the 4 tanks? Well, it does say the 4 tanks are to be filled completely with the mixture, so they have to be completely full. Well, Karina has 3,232 litres, and space-wise, she has 3,216 litres. So she has more fertiliser than she needs to fill the tanks. Only a little bit extra, but that does mean, yes, she is going to be able to fill the tanks. So we would say, yes, And you could write next to that, she will be able to fill the tank. She can write any sort of explanation you want with it because she has 3,232 litres and the tanks are only 3,216. So she is going to be able to fill them. And there we go. That was a functional volume question dealing with cylinders and having a little bit of
Okay, so looking at a Venn diagram. Now here we have the universal set and it says the numbers 1 through to 10. So they are the only numbers that we're allowed to put in the Venn diagram, and all of those numbers have to go somewhere in the Venn diagram, whether it's in A, B, the intersection, or around the outside. It says in A we're going to have square numbers, and in B we're going to have odd numbers, and B we're going to have square numbers. So if we put... So it says in A we're going to have odd numbers, and in B we're going to have square numbers. So if we write down the odd numbers that are in the list there, we have 1, 3, 5, 7 and 9. And the square numbers within the list, we have 1, which is 1 times 1, 2 times 2 is 4, and 3 times 3 is 9. So there we go, they are the square numbers that are within that list, of course. 4 squared is 16, so it's outside the list, so just the 1, the 4 and the 9. Now the first thing we want to do is have a look if there's anything in both. So we have a 1 and we have a 9. So they're going to go in the intersection. Now as soon as I put them in the Venn diagram, I'm going to cross them off my list. I then have 4 that goes in B, and we'll cross that off. And I have 3, 5 and 7 that go in A. So 3, 5 and 7. So you can see there we have some remaining numbers. We have 2, we have 8, and we have 10, and let's cross those off, 2, 8 and 10. And you can see there I didn't cross off the 6, so I've got 6 as well. So always make sure you cross them off just to make sure you don't miss a number. Now I've got a couple of questions about this. So the first one, it says a number is chosen at random from the universal set, so out of all of these 10 numbers, find the probability that it's in set A, N, B, and that little n stands for the intersection. So when looking at the intersection, we're looking at the numbers here that are just in this crossover part called the intersection. So there are 2 numbers, so we would write this as a fraction and just say how many it's out of. So count up how many there are. There should be 10. This is a good opportunity now to count to make sure we do have 10. So 1, 2, 3, 4 on the outside, 5, 6, 7, 8, 9 and 10. So 2 out of 10, you don't need to simplify that. You can if you want, but just make sure you don't simplify it incorrectly. You could also be asked about the union. So instead of an n, you'd have a u. If it refers to the union, it's looking at all the numbers in the middle and in A and B alone. Okay, so part B here, or part C now, it says find the probability this number is in set B dash. Now the little dash there means not in B. So not in B means it can't be, and let's use a different colour here, it can't be 4, because that's in B, and it can't be 1 and 9. Even though they are in A, they are also in B. So not in B means it can't be either of those positions. So in terms of the numbers it can be these 3 here, and it can be these 4 here. So 3 plus 4, that gives us 7, and again that's out of 10. So there we go, that is looking at Venn diagrams and also some set theory. So in this question, we obviously have a two-way table, but there isn't a two-way table drawn. We just have a lot of information. There are 800 students at a school. They either have school dinner or a packed lunch. 31% have packed lunch, 55% are boys, 60% have school dinners. How many girls have packed lunches? And you must show you're working. Now, whenever we have loads of information like this, we just need to think about trying to draw a two-way table, particularly when it splits things up like this into school dinners and packed dinners, and then gives us a secondary piece of information. And that's why we have a two-way table, because we've got these 2 different things. We have whether they have a certain lunch, and then when we have whether they are boys or girls. So here we're going to go for the school lunch, we're going to have the packed lunch, and we're going to have a total. We are then going to have the boys, the girls, and again a total. And all we're going to do is try and fill in all these boxes. Ultimately, it wants to know how many girls have packed lunch, which is this box here. So our goal is to find the number that goes in that box. So here there are 800 students in total. So 800 would go into our total in the bottom right. 31% of them have packed lunches.
So we need to work out 31% of 800. Now whenever I'm using a calculator, I'll always go for 1%. So I'll divide by 100, which will give me 1%. So 1% is equal to 8. We want 31%, so I'm going to times by 31. That'll tell me how many have packed lunches. And I'll do that on the calculator, and that comes out as 248. So there are 248 students here that have packed lunch. I'm going to tick that off because we're done with that, and we're done with the 800. I can now find the school lunches because I can do 800 subtract 248, which gives me 552. And typically each piece of information that we put in will give us at least one more. Now the next one, 55% of the students are boys. So I can figure out how many boys there are. I know 1% is 8, so if 1% is 8, I can do 55%, so 8 times 55, and that gives me 440 boys. There you go, 440. I can now work out how many girls there are. 800 take away 440 gives me 360 girls. That's that line done with. We're getting pretty close to that box. 60% of the boys have school dinners. So I labelled it as school lunches, but there we go, school dinners. So for the boys, 60% of the boys. So you've got to be careful here because it's no longer out of 800, there are 440 boys. So for this box here, we're going to have to be extra careful. There are 440 boys, so 1%, dividing that by 100, would be 4.4, and 60% of them have the school dinner. So 4.4 times 60 gives us 264. So there we go, 264 go into this box. We can now work out how many girls had the school dinners, because there was 552 students that had school dinners. 264 of them are boys, so that means 288 of them were girls. We can now go straight across. We actually don't need to find the packed lunch for the boys. You can do if you want. It doesn't say that we had to sort of complete a table. We just need to find that highlighted box there. So 360, take away the 288. That's the total girls. Take away the girls that had school dinners. And that leaves us with 72. And there we go. That is our final answer, 72. And using the two-way table is showing our working. I have had to show around the side the percentages that I've done. I think that was sort of sensible to write those in anyway, because we're obviously going to get working out marks in this question. But there we go, we could actually work out the boys that had packed lunch, even though it's not needed. 248 divided by 72, and that gives us 176. And I do like completing that last box, because I can now check just to make sure that they add up to 440, just to make sure I have done my table correctly, and they do. So there we go, I'm happy that my table is complete. And there we go, there's a two-way table. When we're looking at a probability tree, just like when we had to know that the probabilities in a table added up to 1, here the probabilities on each pair of branches add up to 1. So that's the information that we need in order to complete a probability tree. And this one does want us to complete this tree. We don't really need to know about the context just yet. All we need to do is complete it. So to work out the bottom of that branch, we need to do 1 take away 0.13, and that gives us 0.87. And again, use your calculator for these. Don't sort of guess the answers or just speed through them. Just make sure you do type it into your calculator and get them right. So there's that one done. On to the next pair of branches. We have 0.06, and we need our other branch here. So again, I'm going to do 1 subtract 0.06 on the calculator. Take away 0.06 leaves us with 0.94. So there we go. Again, not rushing it, just type it into the calculator, making sure I get that number correct. Now the branches below are exactly the same, so this is 0.94 as well. So there we go. It's always nice when both those branches are the same, just speeds up that process a little bit. Now it says here, for a day that Morgan goes to work out the probability that the train to work and the train home will both arrive late. Now it's quite common on these questions that the route that it's asking for were already given to you. Just allows you to at least answer part B if you can't do part A. So here we are given those two, and all you need to do is multiply the two decimals or fractions, if it's fractions, together. So here, and we're going to write that calculation down, 0.13 multiplied by 0.06. I'm just going to type that into the calculator, double check that we've typed it all in correctly. And there we go, we get a final answer here. And mine actually comes out, and yours might not, but mine has actually come out in standard form. I've got my calculator set up so smaller decimals are given to me in standard form, but actually it comes out for me as 39 over 5,000. Now it's also come out as 7.8 times 10 to the negative 3, which I could convert back. This just so happens that my calculator has done this, so I could go back 1, 2, 3. There we go. I could write it as a decimal if you prefer, if you don't like the look of a sort of fraction or a standard form number here. But actually it would be fine for me to give my answer as the fraction 39 over 5,000. It's just that typically when doing these questions you wouldn't see your answer written like that. But there we go, 0.0078 is the decimal version. I'll write that down here as well, 0.0078. Or, of course, as I said, you can write that as a fraction. But there we go, there is our final answer for the probability tree. Okay, I'm looking at a frequency tree. Now it says here 200 people live in a village, that's given to us on the frequency tree, and then starts to tell us a lot of information. So I'm going to start to fill these in as I read it. So 23, this is already done, 23 people do not have a garden, so that's 23 here. Straight away I can do 200 take away 23 and get the 177 people that do have a garden, and I'll tick that off. 10 males do not have a garden. So I'm looking at the do not have a garden route, and there are 10 males. I can tick that off. 23 take away 10 leaves us with 13. That now adds up to 23 on the do not have a garden route. It says 95 people are male. So this one here doesn't give me a number to put in straight away, but it does tell me that these two circles here that have the males in have to add up to 95. Well, I have 10 in that top circle, so this one has to be 85. And there we go, we've done with that. There's 177 people that do have a garden, 85 of them are males, so if we take away the 85, that leaves us with 92 in the female circle. And there we go, we've completed the frequency tree. Now it says one of the people who does not have a garden is chosen at random. Now this is really important because it says one of the people who does not have a garden is chosen. So we're only looking at the people who do not have a garden. So it's out of these 23 people. Write down the probability this person is a female. Well, there are 13 females and we're only picking out of those 23, so that's 13 out of 23. You've got to be really careful on these questions to read the language. If it just said one of the people is chosen, then it would have been out of 200. But it specifically says one of the people who does not have a garden is chosen. So it was just out of those 23. And there we go. You can leave your answer as a fraction. You don't need to simplify it if it did simplify. And there we go. There's our final answer for the frequency tree. Okay, and onto a plan and elevation. It says here is a solid made from a square base pyramid and a cube. Each edge of the solid has length 6 centimetres. So looking at the cube, that means this is 6, this is 6, we've got 6s everywhere. It says on the centimetre grid, draw the plan of the solid. Now the plan is from above. Now when you're drawing a plan from above, you can, if it's difficult to visualise the top from above, you can always have a look at this base. And the base here is a 6 by 6 square. And that's essentially what we're going to see from the top. So all I need to do, and make sure you leave enough space to actually do 6 by 6, I'll do the length of 6 to start with, and then the length along the bottom of 6 as well, and double check and count them, make sure you've actually done 6. And there we go, I'm going to join it all up from above. And my line there has just gone slightly under, I probably would redraw that, but there we go, there's 6 by 6. Now any edge that you can see, you should also draw in. So here you can see at the top of this pyramid here, there are 4 edges running down to each corner. And we would see those from above. So in terms of the central point in the middle of the square here, we would also have 4 lines going off to each corner that we would see, which is those sloped lines going down from the centre.
And looking at circumference of a circle, here it says a farmer has a field in the shape of a semicircle of diameter 50. The farmer asked Jim to build a fence around the edge of the field and Jim tells him it will cost £29.86 per metre of fence plus £180 for each day's work. Jim takes 3 days to build the fence. Work out the total cost. Well, the easy bit that we can work out here is the £80 each day that he does, so we can do 3 times 180, and that will tell us how much we have to pay him for the actual process, so that costs £540. Now we need to actually work out the cost of the fence. So this particular question is about the distance around the outside. So we're going to look at the circumference formula, which is circumference is equal to pi times diameter, or pi times 2r, depending on which formula you like. So for this one here, we have a diameter of 50, so we can do pi times 50. We'll obviously type that into our calculator, and that comes out as 157.079, and a few more decimals there. Now that would be if it was a full circle. So this particular question is a semicircle, so we're going to need to divide that by 2, and that's going to tell us the curved part, which I'll highlight in just a moment. That comes out as 78.539. Now that is just the curved part here for the semicircle, half of the circumference. We also have to add on this additional 50 metres, so we're going to need to add 50 to our answer to get the total distance around this field. So add 50 and we get an answer of 128.539 and a few more decimals. Now it doesn't really say in this question as to whether we could buy part of a metre. So for this one we would round this up to 129 metres. So we're going to need 129 metres. It costs £29.86 per metre, so we'll times that by the 29.86 pence. So if we do 129 times £29.86, that comes out as £3,851.94. And that is the cost for the fence. Now, of course, the total cost will be the cost of the actual fence plus the cost for the work for each day, and that's 3 days of work. So we need to add those two together. So we'll add £540 to our answer, and that gives us a total cost here and a final answer of £4,391.94. So there we go, that is our final answer for that one, and of course that was looking at circumference of a circle. Just remember, of course, if you were looking at something like the area of this field, to use that area formula, which is pi r squared, and as it is a semicircle, of course, the answer would need to be divided by 2 after applying that formula. But there we go, that was a functional, real-life version of a circumference of a circle question. Okay, so looking at angles in polygons. Now this is an irregular polygon, meaning that all of the angles are clearly not the same size. But it does tell us that angle AED is 4 times the size of angle ABC. So this angle over here and this angle over here, where the E is, that angle is 4 times the size. Now you could approach this like a ratio, or you could write these in terms of algebra. So if the smaller angle is 1x, 4 times the size of that over here would be 4x. It says work out the size of angle AED, which is that larger angle there, and you must show your working. So a pentagon, and we can see the shape anyway, but a pentagon has 5 sides. Our formula for working out the size of the sum of the interior angles is n minus 2, where n is the number of sides, so 5 minus 2, and then you multiply that by 180 degrees. That comes out as 540. So in this question here, relatively nice in the sense that we just need to work out what's missing. So in total, we have 120, 135 and 110. I can add those up on the calculator. So 120 plus 135 plus 110, that gives us a total of 365. So if we subtract 365 from 540, that tells us what's left over, and it leaves us with 175. Now split between these two angles,
4x and 1x. In total, we have 5 lots of x. So we have 5x is equal to 175. From there, we can find the size of 1x by dividing by 5. So 175 divided by 5 leaves me with 35 degrees. And I can now substitute that into those angles, meaning this angle here is 35 degrees, and this angle here is 4 times 35, which we can again do on the calculator, and that comes out as 140 degrees. So for this one here, AED is 140 degrees, and we've shown all of our working there. And that is angles in polygons, and that was a particular type of polygon, which was an irregular polygon. Okay, so for a stem and leaf diagram, it says Hetvi asked her friends how many stickers they each have in their collection, and here are her results. Show this information in a stem and leaf diagram. Now we need to look through these numbers and see which is our smallest. It looks like the smallest is in the 70s. So we'll start this off with a 7 for numbers in the 70s. We'll then have numbers in the 80s, 90s and 10 for numbers in the hundreds. Now, a bit awkward because when we go through this, either we want to draw a draft of the stem and leaf, or we want to leave lots of gaps between the numbers, because as we're going through this, we might find that the smallest number, which I can see over here, I think there's 2 of them, 71, we might not spot the smallest, in which case we're going to have to sort of squeeze a number in front of that. So leave a bit of a gap, just in case you don't spot the smallest number. And then we've got another 71. We've got a 74. I might not spot the smallest, so I'm going to leave a gap. We've got a 77. And there was a 75. So because I've left a gap, I can put that 5 in between the 4 and the 7. And that's now nice and in order. I'll do the same with the 80s. Try and spot the smallest one first. You might spot a smaller one than me, but 82. We've got an 86. We've got an 87. An 88, an 89, and there was an 84 as well, and I've left enough gap to fit that in. We've got 90s, so 91, 94, 98, and there is a 97, so we've got a gap there to slot that number in. And the last one, well, I've just noticed we've also missed an 85, so we'll come back to that. So 103, so we'll put that 3 in, and we've got one number left there. And because I've left lots of gaps, I should be able to fit it in. Ooh, I'm not sure about that. I probably have to rub this out. I've got a 6 there, so let's get rid of that. And let's put the 5 in. Don't think I could have squeezed that one in there, but if you write this out, leave yourself lots of gaps, double check, and there we go. There's our last one. Now I've got to write a key for a stem and leaf. Typically, I just pick the first numbers. So you see here we have a 7 and a 1. So we have a 7 and then the line, and then a 1 after it, and that represents the number 71. Really, really important that we have a key. Without a key, the stem and leaf is kind of pointless, because that could be 7.1. It can also represent larger numbers, but in this case, it represents 71, and we have the key to show that. So there we go, that was a stem and leaf diagram. Okay, so we have 2 transformations here. It says describe fully the single transformation that maps shape S onto shape T. Now this transformation on the left here is called a translation. So this is a translation, which means to move. So it has a movement, and a movement is described using a vector. So we say it's a translation by the vector, and then we're going to say what that vector is. So we need to pick a vertice on the shape. I'm going to go for these ones here, the same one on both, and I'm going to count how to get there. Now, in a vector, the top number describes left and right. To get from S to T, I've got to go left by 1, 2, 3, 4, 5. So that would be -5. The bottom number is up and down. So 1, 2, 3, 4, 5, 6. And that's 6 up, so +6. And there is my description. It's a translation by the vector -5, 6, which means 5 left and 6 up. The next transformation here, we have a reflection. So this particular one, we will say it is a reflection. Now all we need to do is say what line it's been reflected in. So we have a look at the 2 shapes and find the middle of them. So in the middle is just here. You can see there's one square either side of that line. So that particular line that we're reflecting in is called the x-axis. So this is a reflection in the x-axis. Of course, reflection lines can be anywhere, so be really, really careful. So for example, if we did have a sort of, let's just draw a little basic one in, a shape that's reflected from here to here, that would be a reflection in a vertical line going through x is -3. So that one there, we might have to describe the actual name of the line as well. So just be really, really careful. This one was in the x-axis. It's quite common that it is reflected in an axis, but just in case, make sure you know the names of those different lines as well. And looking at a bearings question, this says the bearing of port B from port A is 147 degrees. Work out the bearing of port A from port B, essentially coming back the other way. Now the best thing we can do is draw a small diagram for this. So it says the bearing of B from A is 147. So if I was to draw port A somewhere here and draw in a north line, 147 degrees is past 90, which would be just here, but before 180, which would be vertically down. So let's just imagine it's over here somewhere, and that there is port B. And I'm going to label that 147 degrees. Any position on a bearing diagram, I'm also going to draw a north line in, and there is my north line at port B. Now the bearing of port A from port B is going to be this angle down the bottom, this larger angle here. All bearings have to be measured clockwise. They also have to be given as 3 digits, but this is going to be a 3-digit number anyway. But we measure from north clockwise and giving 3 digits. So this is where parallel lines or angles in parallel lines come into play. There are 2 ways of going about answering this. One thing that I do really like to do with these questions when I have to draw them is I imagine if I had extended the line, this angle here would be exactly the same as the 147. And there are 2 ways of doing this. I will explain both. And that there just extends the line by 147. Now if I was to keep going from A to B, essentially to get back I just need to turn a full 180 degrees. Because we've got this extra 180 degrees just here where we have a straight line essentially turning back round the other way. So the combination or the bearing that allows us to go back is the 180 plus the 147 that we were already going. So that would be, and we can do that on the calculator as well as we are doing this for calculator practice, there you go, 327 degrees would be the bearing. That's not the only way of doing it. What we could have done is looked at these co-interior angles, which add up to 180. So I could do 180 minus 147. And again, I can just type it in on the calculator, and that is 33. And I can take that away from 360, and we will get 327. So lots of different ways that you can approach these bearings questions, but the most important thing is to remember those 3 rules. It has to be measured from north, you have to measure clockwise, and you have to give your bearings as 3 digits. So although I'm writing it as an angle, if I was going to give a 33 degree bearing, I would write that as 033 degrees. But this question, the answer was 3 digits anyway, so we didn't really need to worry about that. But there we go, there is a bearings question. When we have angles in parallel lines, we can also have shapes like this one, where we have a parallelogram involved. So you need to know your parallel line rules. You have co-interior angles in a parallelogram. Co-interior angles are these 2 here, where they are on the same side and make that little bit of a C shape or a backward C shape, and these add up to 180 degrees. But you also have corresponding angles, which make the nice F shape, and you have alternate angles, which make a Z shape. So we're looking at the corresponding angle up here. These 2 are the same. So it's completely up to you on a sort of first step when you look at a diagram, how you start to move around the shape. Now this particular one has asked us to show that angle ABF is equal to 70. And we need to give a reason for each stage of our working. So it doesn't matter how we move along the diagram, as long as whichever way we choose to move, we give the reasons as we go.
So for this particular one, ABF is the angle down here. Now what we definitely don't want to do in a show that question is put 70 here and use the 70 to then find some answers. Essentially, let's just pretend the question never told us that, and as long as we get 70 there, we'll have shown it. So for this particular one, we obviously need to find the angles within this triangle here somehow. And if we can find the other two angles, well, we know that the angles in a triangle add up to 180. Now the really nice one here is this one here, opposite the 35. Now this type of angle is called a vertically opposite angle. So although I use the word opposite when I talk about them, you just need to be very careful here because these are vertically opposite angles. Now vertically opposite angles are equal. So that's the reason that I would write down for these. And there we go, vertically opposite angles are equal. Now you can write sort of bullet points down in your open space, or you can label it around the diagram. If you label it around the diagram, just make sure it is really, really nice and clear. You don't want there to be scribbles around the diagram and it potentially not to be read very well. So do make sure if you're labeling it on the diagram, which is perfectly fine to do, you write that very clearly. Now we talked about the 75 and all the different angles we could find moving up the diagram, and there are probably 3 different ways of solving this. A really nice way of getting this angle here is knowing that opposite angles in a parallelogram are equal. So we have this large parallelogram here and that angle is the same as this 75 over here. So opposite angles in a parallelogram are equal. And there we go, I can label this here. Opposite angles in a parallelogram are equal. And there we go. Are equal. And now I can find that final angle in the triangle. And if we do 75 add 35, we get the answer 110, and 180 minus 110 is equal to 70 degrees. And there we go. And the reason behind that bit of working out angles in a triangle equal 180 degrees. So I would write that down, angles in a triangle, you can write sum to 180 degrees, or I'm just going to write equals 180 degrees. And there we go. So there's my final answer. Now I could have found this potentially in different ways, and there's absolutely nothing wrong with doing so. I could have moved up to here and found that this was 75, as corresponding angles are equal, and then I potentially could have jumped between these parallel lines here, because we have a parallel line here, and this nice connecting line joining them together makes that nice Z shape. So that 75 that we drew over by A is also an alternate angle with the one that we've just drawn. So I could have actually moved across the shape using parallel line rules, but as it turns out in this particular question, I could actually use no parallel line rules other than, I guess, your opposite angles in a parallelogram. So there we go, that is one particular way of moving around this shape, but the important part with questions like this is just to find any angle that you can and just see how close you can get to the one that you're actually looking for, and not to focus in too much on the one that you're being asked to find. Just find any angles, and as the puzzle starts to build up, you'll tend to find that you find your way over to that angle anyway. But there we go, there were some angles in parallel lines.